Well, here we go, I guess. 7 a.m. Sunday. Is it working? I can't tell. Wait. Oh no, they changed the UI. Oh. Looks like it's working now. Nobody's here yet, so no point starting. Probably wasn't the best idea to stream at this hour, but oh well. I need to get I want to get this card over with, so so the room being quiet is annoying me, so that's gonna oh no, the audio broke. Well, that's fun. Is that a photo? Yes. This is going to be interesting. This is either going to be very long or very short, because I have not pre-tested the card. That's kind of the point of the stream. So, like, the last time I turned this on was, I think, like a month ago. We'll see if it turns on again, because, like, the thing is, the card still has, at least as far as I can tell, a short circuit on the VDDCI rail. Actually, it's not even as far as I can tell. There's still a short circuit on the VDDCI rail, and the card seems to work in spite of that. So, that's what we're testing today, is like, how much does it actually work? And it could actually work for several hours, in which case, cool, I have another Vega to mess with, and what I think is the more likely option is it spontaneously dies again, and this time for good. Was it mined on? Oh, I don't know if it was mined on. But it did show up with a whole bunch of, like, hardware issues that I fixed. And then, yeah, anyway, there's a whole story. Like, I'm just waiting for people to show up because, like, you know, I am very good at, like, this whole production thing. I don't know, maybe I should have just started off and let like, people watch the VOD to get the full story, but... Yeah, you've seen Cyberpunk Edgerunners? No. I don't really watch things. I prefer reading because it tends to be faster at, like, getting to the information that I want. So... Also, what annoys me is I took so long to commit to doing this idea that, like, I don't actually remember the repair process for this card. It was quite an adventure. I do have notes, but, like, the notes seem to be missing some details, because I seem to, yeah, like, there's, so one chip got replaced 3 times, but the notes don't really specify why exactly it was 3 times, and then another chip got replaced once, but it's never mentioned why. I guess it was dead. Or at least at the time I thought it was dead. Either way, that chip isn't really doing anything on the card anymore. It is still there. Yes, that chip is still on the card, but it isn't actually doing anything. Yeah, I don't know. You know what? Screw it. We'll just start right here. And if people want to get the full story, they're just going to have to watch the VOD. Actually, what's really cool with YouTube live streams is you can literally just start the live stream at the beginning, watch it at 2x speed, and then you'll catch up to whatever part is actually live. So, you know, You can just go back in time and then like speed time up to catch up to present time. It's amazing. Um, anyway, so let's get into this. So this is an RX VEGA 64 that didn't work when it was sent to me by a viewer of the channel. Um, and basically, I told them that, well, this is a Vega, so there's like no way in hell that I'm ever going to be able to fix one of these because Vegas tend to die and they tend to die permanently. So I figured this would just be a really good parts card because Vegas have a lot of nice parts on them. Um, so yeah, so I said like, look, I'm probably not going to be able to fix this, but you know, if you're okay with just sending it over as a parts card, that's totally cool with me. And so they sent the card over. Um, and I got to working on trying to fix it. And on initial inspection, like this card is very clean, which is nice. Nothing, you know, nothing obviously wrong with it. Now once I took off the back plate and like from the front, nothing wrong with it again. Like no immediate, like you don't see any burnt MOSFETs or anything, no cracked like nothing. So yeah, card looks good. And we get to the back of the card. And I didn't actually notice this at the time that I was taking this photo, but this hand gate, and I'm very happy that this photo actually shows this, because when I realized that this AND gate was smashed, and this is like a dual AND gate, yeah, when I found out that this thing was smashed, I was worried that it was my fault, but it wasn't my fault because it's in this photo, and this photo is like earlier than me finding out about this, so unless I like broke it when taking off the back plate, but I think this was already there. Anyway, so this thing's kind of smashed, but I noticed that way later because the main, like the first thing I do with any dead GPU instead of really going through like a thorough visual inspection is just measure for short circuits because that tends to tell you a lot more things a lot more quickly. So obviously for checking short circuits on a card like this, well, you know, for the two 8-pins over here, you just check like resistance from the input filtering inductors to ground. So like these screw holes or like this tab on these capacitors or like, you know, the display ports, there's ground everywhere. So anyway, I check those, no short circuit, those are fine. So that's no big deal. We don't need to worry about that. And then I go to check the PCIe slot, 12 volt PCIe slot, also completely fine. 3.3 volts, which I'm pretty sure is this thing right over here. Just judging by the, you know, solder mat, like the mask over here. But anyway, you can go to Wikipedia, figure out which of the PCIe pins is 3.3 volts. Anyway, 3.3 volts measured 65 ohms, which is a lot, like, it's not super ridiculously low, but it is suspiciously low. Like, it's not supposed to be 65 ohms. Also, I do have a pile of random dead Vegas, and I think those mostly measure in like the hundreds to kilo ohms range. For some reason, I didn't decide to put that in my notes. That would have been, you know, a good thing to put into your notes. Because yeah, I also have working Vegas. And yeah, they all measure significantly higher resistance on 3.3 volts than this thing did. So the first thing I sort of wanted to figure out was like, okay, so 3.3 volts has something broken on it because the resistance is too low. And then the other thing that I went and checked is, of course, the resistances of the main power rails. So VCore on a Vega is very low resistance. I think it's typically like 0.1 ohms or something. So VCore is good, as far as I can tell. Like it's not like you could like my multimeter is sensitive enough that you can kind of tell if like, you know, I'm measuring like across here versus here, and it's like very slightly higher resistance taking this measurement than taking like from ground to ground, and I'm like, okay, so VCore seems to be good. That's always an annoying thing with a lot of modern GPUs is that, especially like big power hungry modern GPUs, the core resistance is extremely low. So checking if something's wrong with the vCore VRM tends to be very difficult. Anyway, I checked the HBM rail, that checked out. So I think it was like 22 ohms or something like that. And then I got to the these things over here. So we got like VDDCI, which didn't look suspicious at the time. Then 1.8 volts, which is this rail over here. This measured 18 ohms, which is not okay. That is way too low. This is supposed to be like, I want to say kilo ohms range. It's definitely not supposed to be 18. So this has something wrong with it. And then this one checked out as fine. So this one down here was okay. So that kind of covers the whole like resistance checks. It's just like, yeah. So we have a like obvious failure. There's something wrong with 3.3 volts, and there's something wrong with 1.8. So let's get to fixing things. So 3.3 volts. The only two chips that I could really like figure out and suspect of being like responsible for the 3.3 volts being really low resistance was the 35217 and this thing. And I figured that, well, maybe the VRM controller just died. That does sometimes happen. And so I desoldered the 35217. That did not remove the short circuit on 3.3 volts. And this is why you should do something better than just guessing if, like, hey, this might have died. So that wasn't a very clever idea on my part. And that wasted a ton of time because when I removed this chip, I dragged it this way and I shaved off. Actually, I think I pushed it this way and this way. And I ended up shaving off like a whole bunch of these SMDs, or well, shaving off. When you're hot air desoldering a chip like this, like everything around it ends up melted, right? Like everything around it at that point is like free flowing by the time this thing lets go of the board. Because there's a massive ground pad under this thing. So getting this thing up to temperature means that everything around it is up to temperature as well. And so I pushed it in like two directions, and basically I got to repopulate a whole bunch of these components off of a donor Vega because dum-dum. So that was a huge waste of time. That's also why some of these components are a little bit wonky because, yeah, I literally had to like repopulate, I think, like all of this over here. Think all of this, and I guess these got caught in the crossfire at some point. So, yeah, so that was a fun waste of time. Anyway, as it turns out, the reason 3.3 volts had a short circuit is this chip. Yeah, this chip was just like, well, I say short circuit. Well, the reason why 3.3 volts was at 65 ohms of resistance was this chip. And removing this, and then I just replaced this chip with a donor chip off of a different Vega. So to get it off the board, obviously I just used hot air again because I don't have like I do believe they make like special clamp things that you can use to like desolder these kinds, like this kind of package, where it like heats up both sets of legs at the same time. I don't have that, so I just hot aired it off, and then I used the soldering iron to like I hot aired off a donor one of these off of a different dead Vega that I have, threw that on there. That's fixed. So that's sorted out. So after all of this, we get to the whole like, okay, 1.8 volts is like not like the resistance is way too damn low. Why is that? So I started investigating because the funny thing is it wasn't like a really obvious short circuit. Like it wasn't shorted from the input to the output. It wasn't like 18 ohms to ground is low, but like where is that 18 ohms? Like what is that 18 ohms? Like where is that connection happening that has 18 ohms of resistance? And I couldn't figure it out. There's this jumper over here for 1.8 volts that I just experimentally took off, and that didn't do anything, so that was also a waste of time. And anyway, so I was just kind of poking around, and then you know I just got the idea like, well, I'll just desolder the 5230, right? Because this is the actual controller and the drivers for the dual NFET that you have on the front of the board. So this chip over here, this is actually two MOSFETs, and the chip on the back handles the actual voltage regulation and the switching of the two MOSFETs in over here. And so, yeah, I basically just was like, so this was basically another guess on my part, but this one was less stupid than the other one. Or was it a guess? I'm not sure. Oh, no, it wasn't a guess. My notes do actually mention what I did. Yeah, so so this chip was getting really, really hot when trying to turn the card on. And the way I figured out that it was getting really hot is I just put some alcohol on it. So after I fixed whatever was wrong with 3.3 volts, I plugged the card in because it's like, well, I don't think it's just like, it's not going to send 12 volts to the 1.8 volt rail, so it's not just going to blow up the GPU, probably. If it did send 12 volts to 1.8 volts, then bye-bye GPU. Nice knowing you. But yeah, like there wasn't a short circuit on 12 volts, so I was like, okay, you know what? We'll try turn this on. I'll just put some alcohol on the board and see what gets hot. And yeah, this thing got very, very hot, so it got replaced. Um, so and now, instead of this thing getting very, very hot and the card not working, it sat at 0.65 volts. The output did, not this chip. So like here, you had like 0.65 volts, which is not 1.8 volts, so still broken for some reason. And I couldn't figure out why it was broken, so I was like, okay, I'll replace the feedback resistors, which I don't know where they are. I also replaced the V-in resistor, and that was probably the actual like better idea, which is I think it's these two resistors over here. So this is pretty standard practice on a lot of boards, is that they'll have like the main power supply for like a VRM controller or something. There's going to be resistors, or well, usually it's one resistor. Here it's two resistors that basically connect the power supply to the chip. And that resistor can basically act as a bit of a fuse if something goes wrong with the chip. Though a lot of the time that doesn't happen. Like the chip will die and the resistor is still perfectly fine. But either way, I decided to replace these. So after replacing the resistors, the output was 0.3 volts, not 0.65. So something changed, but it's still not what it's supposed to be. And all of the other voltages on the card are still 0 volts. So I put another 5230 on the card. So this thing got replaced again. I also gave it a new, this multilayer ceramic capacitor got replaced as well. And the card finally put out an image. Yay. And then it promptly burned my hand because there was a cracked capacitor behind the core. Wait. Somewhere in there, the AND gate also got repaired. Yeah, this is the issue of making a video about repairing something like a month after you repaired it and your notes being kind of trash. Anyway, so remember earlier I mentioned like, oh yeah, there was this AND gate that was like kind of smashed. Yeah, so I unsmashed it. That's not true. I replaced the AND gate and had to run jumper wires for everything. I'm pretty sure there's a wire that's going like this, and then there's one over here. So yeah, that was fun to do. Luckily, at least one of the pads or two of the pads were still... Actually, I think it's just one. I think it's literally just this pad that was still good. But at least there was one pad still attached to the board, because that means this thing isn't like Actually, it might have been easier if it was free floating. But anyway, yeah, there was at least one pad, so I just rewired it. That was fun. Very fiddly. If you're looking at this like, man, this photo quality is garbage, it's like, yeah, because this thing is tiny, right? Like, these screw holes are M3. So if I'm not mistaken, that means the screw is like roughly 3 millimeters. Yeah, this whole chip is like 3 freaking millimeters. Yay. Actually, I think it's smaller than that. It's like 2 millimeters. So yeah, that was very fun. Especially like this connection and this one, because this one's like really short. So that makes it more annoying. And anyway, so somewhere along in the process, this got fixed. I don't remember what order things got fixed in, unfortunately. Anyway, but eventually I get the card to finally put out an image, and it promptly burns the crap out of one of my fingers because there's a cracked capacitor behind the core, which I'm not sure... Oh, it was cracked. Yeah, like this capacitor wasn't doing great, but I didn't, like, it didn't register to me that, like, hey, that capacitor seems to be having some issues. So anyway, cracked capacitors, and this is I'm not sure if it's a V-core or a VDDCI capacitor. Either way, cracked. And basically when I like test boot cards, like I had this little heatsink, and so I was like sandwiching the heatsink onto the core with my fingers. This really hurt. So that capacitor, yeah, burnt my finger, because I was like holding the heatsink onto the core. So that was fun. This card was a wonderful adventure. Anyway, so cracked capacitor, and at this point, I think VDDCI died or something. Anyway, I replaced that capacitor. Again, like I have tons of dead Vegas. So finding a replacement capacitor was trivial, and it's just you hot it, like you heat up the entire board, you desolder the capacitor, you throw a new one on, no big deal. So new capacitor. Oh, and then at some point in time, the other 5230 got replaced. So this one's for 1.8 volts, and this one's for VDDCI. And somewhere along the way, I figured out that this one also was broken. For like, it also was like giving like this one had that weirdly low resistance. This one was also measuring like weirdly low something, and it wasn't outputting a voltage. So I just decided, well, if this one was dead, and it was dead, the original one was dead. I don't know if the second one was also dead, but because this got replaced 3 times. But the very first one was definitely dead. The second one I don't know, and the third one, that one stayed on the board. Anyway, this thing was also like misbehaving, and I'm like, okay, well, this one was dead. Maybe this one's dead too. So this got replaced, and bam, card finally works. So we have like list of things that got replaced. This thing got replaced 3 times. Some of the supporting components got replaced. This got replaced. Actually, it would be better to do it on the like full board picture. So, AND gate got like this got replaced and rewired because like the pads are ripped off, and yeah. This thing got desoldered and soldered back on because I'm an idiot. Bunch of the components had to get replaced again because I'm an idiot. This got replaced because it was dead. This capacitor got replaced because it was dead. I've mentioned that got replaced, as well as some of the passives for this chip got replaced. So, yeah, so after that wonderful just adventure of, all around the board, things are getting replaced, Card finally puts out an image, gets into Windows, installs driver. I am so excited. I start Firestrike, I run Firestrike, and I just leave Firestrike running, right? Because that's what you do. Well, you need to verify that the card can like sustain a load for some time. And so, I'm just chilling, doing whatever it is I do, probably Reddit. And the card's sitting behind me running Firestrike, and I hear a pop, and the screen goes black. So I take the card out of the system. And because it was a pop, I'm like, oh, there's going to be a short circuit now. Like it like that like usually if you hear a pop, that's like probably a short circuit. Something shorted out. So don't even try to power cycle the card. Like take the card out, start looking for short circuits. So I start looking for short circuits, and what do I find? VDDCI, right? So from this end, like this is a VDDCI filtering capacitor. From this end to this end, 0.2 ohms, which is extremely low. Like, that's the same kind of resistance that the core has. So I'm like, okay, the MOSFETs died, right? Like, one of the MOSFETs is dead. Replace the MOSFETs. It'll be fine. Yeah, about that. So I desolder the inductor, I desolder the MOSFET, and from here to ground, still 0.2 ohms. There is no short, so this MOSFET, that was completely fine. No, there was no short circuit in the MOSFET. There's no short circuit in the VRM driver, like the controller for this VRM. It's fine, everything's fine. There is simply a short circuit, probably somewhere in the core, or somewhere else on the board. There's like a 0.2 ohm short circuit somewhere on the board. And I'm like, oh, so it's dead now. Like, the memory controller just died, was my theory. Like, I was like, okay, memory controller just kicked the bucket. There's a short circuit in the silicon. There's nothing that can be done. But, just in case, I was like, okay, but you know what? I'll still try to, I'll just force power into the VDDCI rail, see what happens, right? And so my idea for forcing power into VDDCI rail is like, okay, what convenient low voltage, high power source do we have on a Vega PCB? And of course, it's the VCore VRM, right? That's the 12 phase monstrosity that can output hundreds of amps and will absolutely not care about a 0.2 ohm short circuit. Like if there's a 0.2 ohm short circuit across like from the VCore VRM to ground, the VCore VRM will actually just burn that short circuit into nothingness, assuming that short circuit doesn't have a heatsink attached to it. So I was like, yeah, I'll just like run a jumper from here to there, and like either it'll turn on or it'll go up in flames. Well, actually, I really didn't think it would turn on. I figured like it'll either burn the short circuit to the ground or it just won't work. So I attached a jumper. Now this jumper is no longer attached to the card because this one's very tall and it doesn't fit under the heatsink. But why would I replace the jumper if like, like, because it turned on. And the crazy thing is, so I was like, oh, it turned on with the jumper, so it burnt the short circuit. The short circuit is gone, right? Like that was my theory, is like it just burnt the short circuit. It's no longer there. So I desoldered the jumper, and because the thing is, the card like turns on, puts out an image, everything. Like it just basically works. I mean, I didn't run any workloads on it because this ain't gonna cool it. But it did put out an image, and I'm like, okay, so the VCore VRM like destroyed the short circuit was my theory. So I desoldered the jumper. The short circuit is still there. So the card is still shorted out on VDDCI. Like, yeah. And the crazy thing is, it wasn't like, you'd think like, oh, maybe some capacitor somewhere got really hot. But nah. It just kind of worked. Like nothing on the board got particularly hot. It's just like, yeah, there's just like VDDCI now has a resistance of 0.2 ohms and like it just kind of seems to work. So yeah, this doesn't fit under the heatsink, so I've since replaced that jumper with a smaller jumper. And now we're going to get to find out if this card actually still works or not. And if it'll just like up and die and fire strike again. That's literally the point of the stream. So this will either be very long or very short because and I haven't turned the card on in like a month, so I don't even know if it still turns on. So I might look like a complete idiot, like a crazy person. It's like, yeah. Yeah, let's see, shall we? Because like I want to know if this actually is a viable way of like fixing Vegas with shorted VDDCI. That is like that's insane to me. Because yeah, because it should just be dead. Like the memory controller should just be dead at this point, as far as I'm aware. Or there's there's a short somewhere. Like it can't just work. That doesn't make any sense. But anyway, we're gonna try turn this thing on at this point. So yeah, here we go. Hopefully it works. And if it does work, then yeah, we're just gonna like run Time Spy on it. Yeah, we're gonna run Time Spy, not Fire Strike. Not because I think like Fire Strike, actually like Time Spy's heavier than Fire Strike is. Well, here we go. I don't see any fire. Oh, and it stopped working. Really? Oh, it died again. Short stream it is. Yeah, looks like it. Yeah, I just got stuck on 97. Okay, I'll go get the multimeter. If I can figure out quickly what's wrong with it, then we might go on. If I can't, like, I don't have the... like, I'm not set up to record the actual repair process, so, like, that's not happening on stream. 1.8 volts is at 0.6 volts. I swear this card is cursed. So I actually, like, I could try fix that. Like, I think at this point, it might be best to just, like, not use the built-in power delivery for 1.8 volts and use, like, an ampule. Oh, wait a minute. I measured the wrong thing. I measured the 0.6 volt rail. I didn't measure 1.8. Damn it. Well, since I already pulled it out of the system, I may as well check for short circuits. Yeah, no, everything looks good. So I guess it just actually permanently died at this point. Oh, and HBM is at 50 ohms, which is what it's supposed to be. There, I didn't remember that correctly. It's not 20. I swear there's some HBM GPU that's supposed to be 20 ohms, though. Maybe it's like a specific variant of Vega? Fury, maybe? Anyway, we'll try turn it on again. Because, like, there's nothing obviously wrong with it right now, so... Actually, wait, I'll just check the 3.3 volts. Nah, 3.3 volts is kilo ohms range. Fun. Also, I'll try boot it without the, not into the capture card, but into the monitor directly. And this time I'll check the actual 1.8 volt rail instead of the 0.6. Well, it looks like the memory controller did actually just die, because 1.8 volts is at 1.8 volts. Um, and VDDCI is literally jumped to vCore, so... I guess one more option is that I could try boot it on a different motherboard, because I've never actually, like, I don't think that's going to make a difference, but, you know, like, I have another test bench set up already, so I may as well try. And it booted. So, for some reason, it just hates the Apex. The hell? Freaking E-cores, I swear. This Vega hates E-cores. Well, I do too. I approve of this in these cards. It, it... Yeah, probably CSM, actually. Freaking modern hardware. See, this... The funny thing is, I tried a different Vega, like, as prep for the stream, to make sure that this would just turn on. And it's like, oh, I'm actually just not, like, I'm not going to turn on, so... GT1030 to the rescue. Because, yeah, the thing does turn on in the Giggle board that I have, the B550, which defaults to CSM, I think. Or it's on CSM. You know what would be really funny if now the GT1030 also didn't post? That would be like peak Z790 experience. Just like it gets progressively less and less functional the more I try to use it. It used to be that it just didn't want to stabilize RAM overclocks, and now it can't even post GPUs. Okay, no, the 1030 booted up. So I'm guessing it's a CSM problem. Oh, wait, why is the CPU cooking? Oh, I must have accidentally disconnected the pump when I tried to disconnect the fans. Oh, yeah, oh, yeah, I definitely disconnected the pump. Yeah, because I wanted to disconnect the fans that I was using for the GPU, and I didn't realize that the fan headers were like GPU, pump, GPU. So I grabbed two of them, and I got one of the fans and the pump, so that was dumb. Is it going to go through B2? Okay, yeah, it's doing B2 now. Cool. So now it should work. And honestly, this is why for like, if you're messing with GPU repair, you should get something ancient as your like test board because, well, actually, I guess if you're repairing modern cards, that might not work. But if you're messing with repairing old cards, get like an X99 board or something, or even better, like AM3 Plus, because it'll boot really quickly and it'll boot everything. Actually, X99 will not boot quickly, but like AM3 Plus does. There's nothing more fun than trying to check if you repaired a GPU and then waiting for memory training. That's always just a great time. Now it'll post, right? Right? Are you kidding me? Why? I hate this is just like this actually is one thing I do hate about modern like hardware is like I have a lot of old GPUs. Like a lot. Like most of my like actually the vast majority of my GPU collection is old junk. Um and then you plug your old junk into your fancy high-end modern motherboard and the motherboard refuses to boot it. Okay, I guess we can try put it on the chipset. Where even is the chipset PCIe slot on this thing? Oh, it's all the way at the bottom. Oh my god. I mean, I guess we could just run it off of the B550 board, but So it just occurred to me, with the way I have the test bench set up, that's not going to go in that PCIe slot right now. That's horrifying. Like, it's one of those open-ended PCIe X4 slots, man. The thing is freaking leaning over. Oh, it still doesn't work. Fine, be like that. I'm just gonna use the bloody B550 motherboard. I locked it. Man, I go through all that, like I do all this setup, and then of course nothing bloody works, because why would things work? When you point a camera at something, it immediately breaks, for reasons no one will ever understand. The other way Vega works in the Apex, I don't know why this one doesn't. There, now you can see the post code. Wonderful. Is that Mobo covered in Plastidip? Yeah, I ran it on LN2. Not on camera, but it did run on LN2. With the 5950X. If you look at my hardware bot profile, you might see the scores that I did with this board. They're not very good. 5950X on LN2 is a workout. Especially mine, because like the FCLK was like hard stuck at like 1200 in order to be able to bench like minus 150 or something. Like I couldn't like, yeah, no, it did not run well. Yeah, see? It boots! It boots! Like freaking Intel, man! I'm not crazy. The damn card does work. It's the Intel that doesn't work. Oh, the mouse and keyboard aren't plugged in. And now we will proceed to watch Time Spy. Yeah, so the drivers are up. The thing is, the fans are not, like, controlled by the GPU right now, so I might have to go into the BIOS to max them out. Yeah, power color Vega. Oh, the render. No, it does wake it up. It doesn't wake it up to full 3D clocks, but it does wake it up. Oh no, we've got a grossly inappropriate wallpaper. Oh, there's no music either. Man, this stream, from bad to worse. Anyway, what did I want to do? Oh, right, fix the wallpaper. Wait, no, that's AM5. Do I not have an AM4 appropriate desktop background? Okay, we'll just go with, yeah, sure, the DDR4 overclocking circle. Been a while since this has made an appearance. Oh, man. Makes the board look quite rusty. It's blaze orange, it's just not thick enough to get the, like, really, like, it doesn't have the saturation it's supposed to have, because it's not thick enough. The thing is, I've found that if you layer the Plastidip really thick onto a PCB, it has a tendency to lift itself off. And you get, like, air gaps under it, which is, like, super annoying. So, yeah, I don't apply it super thick because of that. And I haven't found, like, you'd think, like, oh, you just do, like, multiple thin coats and then it won't do it. And it's like, nope, because, like, the new wet coat, like as it dries, it, like, contracts, and that's what pulls it off of the board. Whereas if you have a thin coat, that doesn't happen. Oh, I can't get into the BIOS. You've got to be... I even have a go-to BIOS shortcut. See? Why isn't it working? Let and nail polish. Yeah, I'm guessing Let is like designed to not do that. I'm surprised that like, because as far as I know, if you do like plasti dip on a car, that's really not an issue. Then again, I guess cars are mostly very large, flat surfaces instead of lots of little lumpy components. Okay, what did I want to do? Right, max the fan speeds, because the last three, like I don't like if the car dies again, I don't want it to die again because the like freaking cooling was inadequate. Which fan headers is it on? Sysfan 4 and Sysfan 2 are next to each other. Like, you'd think, you know, next to fan 4, you'd find fan 5 or fan 3, but no, it's fan 4, fan 2, fan 5. Fun. Oh, and then fan 4. I like the Vision BIOS, but I might be biased just because I like the Vision board. Like, this is by far my favorite B550 motherboard, even after the SoC VRM exploded. I really wish there was some way for me to put a fuse towards the SoC VRM, but I can't figure out a way of doing that. Like, it's not physically possible because of the way the board is layered. Like, the SoC VRM is on the same power plane as vCore, and basically what I'm thinking is, like, yeah, if the SoC was on its own little island of 12 volts, then you could put a fuse, but it isn't, so I can't put a fuse. That is actually one thing that if I was doing, like, hardware development, or no, if I had like the ability to influence design of a motherboard or a GPU directly, like trying to get like making it so that it's as unlikely as possible for a 12 volts to output scenario to kill a CPU or the GPU, right? Because that's always the worst as far as I'm concerned. And the funny thing is, like, especially on really expensive stuff, you could just, like, put fuses kind of everywhere. Um, like, it's pretty standard practice on older graphics cards to just have a fuse for every power connector, and it's just like... And that works great. In fact, you can even get the 3090 Ti Supreme X from MSI has, like, a fuse for each 12-volt region. And then you get to 4090s, and at most you can hope for having a fuse for the memory, as well as the PCIe slot, though the PCIe slot isn't really powering anything that dangerous, so... well, I shouldn't say that dangerous. Technically, 12 volts going somewhere where 12 volts shouldn't doesn't really... Like, it doesn't matter where the 12 volts is coming from. So no, 12 volts from the PCIe slot would still be dangerous. Anyway, so we are now in Windows. The card is running. What do? Guess we open GPU-Z and 3D Mark? Where is 3D Mark? Those are scores. Not, there's the bench. One downside to this desktop background is I can't see anything. It's way too noisy. The orange was actual rust. Nah, I wouldn't. Well, I'm not sure what I would do about actual rust on a board. Well, we're in Firestrike. No, I don't want the random clock things. I want GPU temperature and hotspot. Those are absolutely critical. Oh, and memory temperature is a good one as well. And VRM temps, why not? Wait, 19 degrees? That doesn't seem right. The room feels comfortable. Though that might be just because, like, I had, like... I think the VRM temperature sensor is underreporting by, like, 5 degrees or something. There's no way it's at 19. The room is not that cold. VRM is at 28. Oh yeah, it's definitely underreporting. I guess time spy then. Let's just do like a baseline run to see if it scores the way it should. Ultrasonic cleaner for rust? I guess that would work. I'm more thinking like what kind of fluid would you put in it? Because if you put water in it, it's just going to rust more. Then again, I'm not sure where you would get rust on a board, right? Because the tin, like there's not really any iron anywhere. And tin creates like an oxide layer that, as far as I know, is pretty resilient. Not playing industrial noise in the background. Oh, that might show up later in the stream. Copper rusts green. Yeah, but there's not, like, you don't really have exposed copper on most PCBs. Like, that's like unpopulated component pads is where you get copper. Though I have seen cards where, like, the screw holes, because you have the, like, plating around the screw holes, right? That'll actually, like, I've seen cards where they're corroded, and that'll go green. But everywhere else, you get, like, this weird white-ish residue, usually. And that's, like, from, like... Actually, no, you do get green as well. When you have, like, a short... Like, if like, water damage will put, like, green and white residue everywhere. I'm not sure where the green comes from. Maybe, I guess, the copper in the... like, in the solder? But it's like, by as far as I know, the percentage is really low. I guess maybe from the pad under the solder? Dunno. IO port shields and ports are steel? I think the IO bracket itself, no. I think they might be nickel-plated copper. Or not nickel-plated. But, like, so I have this GTX 760 that I recently picked up that was, like, super corroded. Especially, like, the I/O ports were, like, really bad corrosion on some of them. And my idea was, like, oh, I'm just gonna, like, sandpaper off the corrosion, because it was really bad. And I figured, like, yeah, you can just, like, it looked really bad, but it didn't look really deep. So I was like, oh, I'm just gonna sandpaper it off. And there's, like, one spot on the DVI port thing. That 760 works, by the way. It's fine. But the DVI, like the cover plate of the DVI port, there's like an area that's gone like pinkish. So I think it's copper under the plating. Everything oxidizes, yes. But rust specifically is iron oxide, as far as I know. Like, you don't call... oxidized copper, rust. Like, copper doesn't rust. Iron rusts. Everything else, like, oxidizes or like, has corrosion on it. This thing runs. This is ridiculous. The card has a jumper on VDDCI, and it just works, unless you put it into an Intel motherboard. Near the beach or sea for a while. Yeah. It's actually the, like, one like, sort of weird concern I have about, like, being in the UK is, like, man, it's pretty humid here a lot of the time. But I haven't really noticed any, like, corrosion issues on anything that I run. So... And, like, I'm not even, like, that far... Like, I'm relatively close to a large body of water. So it is actually quite humid on the regular. But I haven't noticed any corrosion issues, so... I guess, I might just be paranoid. Anyway, 744, like, that's what you'd expect for a Vega at stock, honestly. Also, 5700X3D is, like, surprisingly decent. for Time Spy. I was kind of expecting it to be worse, so obviously what we need to do is blow the power limit up, because cards running like max temp was 63 degrees. Like, if the short circuit on VDDCI isn't gonna kill it, I am. Okay, no. That's not actually the intent of the stream, is not to blow the card up. But, like, if I can verify that this card actually works, then I might end up, like, benching it. Though, ideally to bench it, I'd like to run it with the 14900K. So I need to figure out what the hell is up with that. It does have dual BIOS, so I guess I could try a few different... I guess I could just take the BIOS off of the Sapphire card and put it onto this, and it'll probably work. Anyway, we're going to try run it with new power limit. Or, well, more power limit. Because Vega, out of the box, is very power-starved. Kind of like most modern AMD GPUs. Assault seems to be the main issue. Okay, so I'm pretty safe from that. You get, how to get a U out of... Wait, what? My Asus Strix Vega 64 died. During loading, it would black screen. Sometimes it would work, sometimes not. Trying some workarounds. I broke it with bad BIOS flash. 2 problems to solve if you want. If the card... So here's the main reason why I was like, oh, dead Vega, I'm never going to be able to fix this. Most Vegas, when they fail, they have the interposer fail. And there's nothing you can do about it. Like, it's very... Oh, I'm not sure it's very rare that a Vega will have, like, a power delivery failure, but it is very common that alongside... Like, I've seen other people repairing Vegas, where they're, like, they spent, like, a lot of time fixing, like, a power delivery fail, and then the card is still dead because the silicon died. And then I have, like, I got sent a Vega where somebody was like, oh yeah, this doesn't work. Actually, I got sent 2 of these. So I have one where it's like, if you tweak the mounting hardware just right, it'll work. And then it'll stop working after some time again, because I'm not sure if it's like a BGA issue. I don't think it is. I think it's the interposer. Because you don't even need to heat it up. It's literally like you just fiddle with the mounting hardware a bit and bam, it works, and sometimes it doesn't work. So that's like, the interposer is like, I guess, delaminating from the core, or the connections just like thermal cycled themselves to death. And then I have another Vega which got sent to me with a water block attached, because the owner said like, oh yeah, it's completely dead. And I took the water block off and it just works. So, yeah. And I've not like that card hasn't given me any issues, so I'm not sure if like maybe the water block was like too much pressure, not enough pressure. So that's the thing, is like, if you have a Vega that's acting like flaky instead of like just doesn't run at all, like that's the worst thing, is cards that are flaky. Like if it doesn't put out an image, chances are there's a major hardware failure on there, and there's something that you can like remove or like replace or bypass or like actually fix. And then there's the cards where it's like, oh yeah, it just behaves. Well, I mean, if you have like a card with GDDR where it's like, oh, it doesn't install drivers or something, there are chances are that there's like a broken solder ball under a memory chip or something. But if you have an HBM card and it's doing that, you're screwed. Like, there's just no fix for that, as far as I know, because it's just like, yep, the interposer's going. What you gonna do about it? How to remove GPU if PCIe latch is covered? I usually just use a screwdriver. Vega dies 99% with dead core, yeah. That's why I thought this was going to be a parts card. And even now, it's like, there is a short circuit on VDDCI. I bet you if I remove the jumper that's going from vCore to VDDCI, this thing is, like, going to still show a short circuit on VDDCI. Which is just like, how is it even working? Like, honestly, it kind of makes me wonder if there aren't Vegas out there that got written off as dead because they have a VDDCI short circuit when it's like, actually, you can just, like, shove, like, you could just brute force VCore into it and then it works. Um, Also, what voltage are we running at? Generally, like, so we're also overvolting the memory controller quite significantly right now because normally it runs at, I think it's either, it might be I think it's 0.9 or 0.95 or something like that. So, um, anyway, let's see if the HBM overclocks. Oh, the render test doesn't work. Would you know why Vega 64 would make artifacts on looping benchmark, but the artifacts produced are the same every time on precisely the same spot? At stock? Vega IMC is 0.95. Okay, so we're not overvolting it quite as much. It's only like 200 millivolts above spec instead of like 250. First Vega to run 1300 megahertz HBM. I don't think that'll actually happen. Though if it did, that would be cool. I would just jump the VDDCI on all of my Vegas. Okay, no, I don't. I wouldn't jump the VDDCI on all of my Vegas. That's pretty stupid, but especially because you're feeding like the stock VDDCI power rail is probably pretty clean, whereas what's going into it now has all of the vCore transients, which I'm sure the memory controller is absolutely thrilled about its power supply having like 200 millivolts of peak to peak on it. Um, but as for the artifacts, if it's at stock, I guess what like the thing is I don't know specifically what causes artifacts, but if the benchmark is going through the same loop every single time, without getting reloaded into the memory, I guess there'd be like like when it loads into the memory the first time, there's like a section that gets corrupted, and then that corruption just stays. So you always get the same errors, unless you mean like the digital snow artifacts. Because I'm like you have artifacts where you have like geometry getting like you have like the geometry ripping artifacts where you have like geometry getting like stretched impossibly. Right? You have like triangles where evidently one of their vertices just shot off into space. Um, and then you also get the artifacts where you get like the snow effect, where you have like like a grid of colors across your, like you get checkerboarding artifacts, and checkerboarding I would assume is like a specific like set of bits is actually like erroring out, because as far as I know, most GPUs actually put like the way the frame data is shoved into the memory is actually very specific. In fact, it's so specific that on like AMD GDDR5 cards where there's like a BGA failure, you can tell which memory chip is failing by just looking at what part of the screen is getting corruption. Because you have like like each chip stores like a specific part of the frame, so you can literally just look like, okay, there's like a stripe of corruption right down the middle of the screen. That means this chip is dead. If the stripe of corruption is right on the very one of the edges, then it like means whichever chip handles the edge of that, like that edge of the screen. Um, so if you're getting like checkerboarding or banding like that, I would assume that there's like some bit lanes or just got like not working correctly, and they always cause the same issues in the same spots. Um, this thing works. The HBM overclocks. Okay, we're gonna try 1190, which for a lot of cards is like a big ask, and then if it goes over 1200, I'm gonna be really impressed. Man, now I kind of want to desolder the jumper and like see if the short circuit is there still. Cuz it just doesn't make any sense to me. Like how unless there's like some kind of like what if like a power distribution barrier failed? Like I don't know how the chip is architected, right? But I'm thinking like okay, let's say there's like an insulating barrier between V-core power distribution and VDDCI. And VDDCI got like jump. No, because I'm pretty sure I measured VDDCI to V-core and there was resistance there. Like it like added the resistance of the two of them together. So no, that doesn't make any sense. So yeah, there's a short circuit on this card and it freaking runs, man. Like you can't explain that. Literally cannot explain that. I do not get it. Unless the short circuit magically removed itself. Go check if the short is still there. That is an obnoxiously involved process for a Vega. Because you need to like take the heatsink off and then like I need to desolder the jumper. I mean, desoldering the jumper isn't really the problem, but taking the heatsink off of Vega is not fun. Especially this one, because the heatsink is like... Okay, it's not as bad as I thought it was. I thought this was one of those cards that you have the... Like, there's just screws everywhere. It's not quite so bad. I think it's like 7 screws for the heatsink. It's not like there's some cards where like the heatsink is attached with like 10 or something. But yeah, so it runs. I mean, it just crashed at 1190 HPM, but like that's a like for a lot of cards that's very very high. And the way with the like way I'm like massively overvolting the memory controller, that's really not surprising. Let's try memory timing level 2. Wait, it was actually yeah, it was at 1190. Oh wait, I think advanced control actually causes a bunch of issues. So we're gonna do overdriven tool, which I don't like using, but I don't think we have any choice here. It goes up in increments of 1. Why would you... Wait, this thing doesn't hit 1.12 volt, 1.12 volts. Hey, how much power does it think it's pulling? 330 watts. Okay, that's actually normal for a Vega, so yeah. Okay, we are overclocked. Yeah, so I guess we'll... And also I can't check for the short circuit on camera, but Man, I kind of wish I did the jumper from behind. Like on the back of the PCB instead of on the front. Though it would have had to be longer. I'm not sure if that would actually make a difference. I should have done it on the back. Then I could like check, like then I could desolder the jumper like instantly. So actually if I take the card apart, when I put the jumper back on again, because oh wait, I'm putting it on the back. Yeah, if I take the card apart to check, like to take the jumper off, I'm putting a new the next time I'm probably going to put the jumper back on again. And if I do, I'm putting it back on the back. I'm not putting it on the front. Because like, on the front, I need to take the heatsink off to get at it, which is stupid. I don't know why I didn't think of that the first time around. Actual HBM voltage is fixed. Is that actually for the IMC? So the thing is, so I think to get the true answer, you'd have to ask somebody at AMD. My, well, okay, yeah, my theory, because you have a VDDCI rail on the board, right? Like there's a VDDCI VRM on the card, which VDDCI, uh, as far as I know, is generally like the memory controller rail on AMD GPUs. Um, I could be wrong about that. I don't design AMD GPUs. Like, I don't actually know what the I in VDDCI stands for. I assume it's IMC, but like, I don't know. Um, and so the thing is, like, so anyway, so you have VDDCI, and there's a voltage regulator for that on the board, and it always outputs 0.95 volts. Never less or more. Um, and then, of course, you have the HBM VRM, which always, well, depending on if you have a Vega 56 or a Vega 64, it either outputs 1.2 or 1.3 volts, I think. Then you have the, like, there's also like a 0.6 volt rail. Anyway, so my theory is that the HBM voltage that you get in the driver is actually for some kind of like memory controller to core connection. Not, or maybe it's for like like, you know how Ryzen has like VDDP and it's generated off of the main memory power rail, right? Like VDDP is produced from like VDDIO, I think, for Zen 5. Man, the core on this thing sucks. Well, I mean, if this thing dies, at least it'll not be much of a loss. Wait, was that even a core crash or maybe HBM? I'm gonna put the HBM back to 1150. Because that's like a nice safe memory speed. But yeah, so I'm thinking it's for some like kind of like there's some kind of voltage somewhere that's derived off of vCore, and that's what the like memory related voltage derived off of vCore, and that's what the HBM voltage rail is for. It's not snow or checkerboarding or vertices, and with like sparkles. Oh, with a visual blooming effect. Huh. Okay, if it has blooming artifacts, I would go try. Do they go away if you underclock it? Because honestly, those sound like core instability to me. No, don't undervolt it. Just lower the clock. Like, in order to successfully undervolt, you need to, like, start with something that actually works. Right? You don't start with unstable settings and then try to make them less stable by lowering the operating voltage. Unless it's overheating. But even then, like, if it's overheating and you lower the voltage, that's probably not going to fix the stability issues. It's just going to make it crash, like, error out sooner. Like, earlier. Anyway, I still can't believe that this thing works. Like, it's just running. Like, what the hell? Like, this is why I wanted to do this as a live stream, because this is ridiculous. Like, this isn't supposed to work. Because, like, I was, like, when I got this card to fire up, I was like, oh, I was just gonna die. This is just gonna die. And I'm like, and my, like, many hours of trying to fix it will be a complete waste of time. I mean, I had fun trying to fix it. Like, the way I look at every failed repair attempt is like, At least I'm getting like hot air soldering practice and that kind of thing because I don't, like it's not like I'm a repair shop, so mostly because I don't trust myself to repair other people's stuff. I've occasionally repaired stuff for people, but yeah, it's not um it like I'm not offering it as a service because it's like I don't trust the things that I do. And like and my goal with the repair skills is mostly like I want to be able to repair random junk that I buy off of eBay or stuff that I break. Um, Also, I don't know why I keep letting the CPU test run. Kind of a waste of time. So evidently the core isn't the issue, it's the HBM that was failing last time. Which makes sense. I mean, the memory controller's probably absolutely thrilled about its new power supply. I was kind of tempted to hook up the oscilloscope to it. Like, hook up the oscilloscope to the VDDCI filtering capacitor. I actually added an extra capacitor. I'm not sure if it'll show up on camera. Oh no, you can see it. Yeah. So there's this, man, I wish I should buy like a long plastic pointy thing. Because, like, it's like, oh, I'm not, like, you're not going to point at capacitors with a screwdriver unless you want to short them out. But, and like, I want to, yeah, long plastic, thin pointy thing. But anyway, so you can kind of see that there's like a capacitor that's like over here-ish by my finger. Um, yeah, that's an extra capacitor because I felt kind of bad about the idea of like taking the noisy mess that is the vCore power supply and feeding it to the memory controller, which would normally, admittedly, I've never checked a stock Vega memory controller, but I've checked other memory controller power rails on AMD GPUs, and they generally are in like the 30 millivolts range. Like they are very, very clean, relatively speaking, mostly because memory controllers don't go through massive load transients like the core, like the rest of the core does. Um, so yeah, I felt kind of bad about like hooking the memory controller to vCore and just, deal with it. So I added an extra capacitor. I don't think it'll really make much of a difference, but I like to, it makes me feel better. But I did kind of want to, like, so I was thinking anyway, like, hook an oscilloscope to the VDDCI rail as well as the vCore to see if there's, like, a difference. Because that jumper isn't very thick, so it probably has a, like, it probably has a pretty substantial amount of, like, inductance, and it might actually be filtering out some of the like, switching noise from the core. There's not really switching noise. I don't want to call it ripple, because it doesn't, well, I guess technically it is kind of a type of ripple, but like I don't. Anyway, just like yeah, I'm not sure about what term. I guess ripple would be the term. Oh well, I don't like saying ripple because like you have ripple from a power supply because of its switching operation, which is like very periodic and it's like literally like it is in sync with the like switching of the voltage regulator, right? If you have a switch mode power supply, it'll like the voltage coming out of it will go up and down with the switching of the MOSFETs. And then you have like transient like response, which is where you get those like massive voltage spikes upwards and downwards. Um, and I feel like you can't use the same term for both of those because that just makes it confusing. Right? Because if you ran this 12-phase VRM into a 300 amp DC load, it would probably produce a straight line. But you put it in, like, you run it into a Vega GPU core and it produces a horrible mess. Anyway, let's give this more core clock. Let's try 1720. Quick question. A friend of mine built an AM5 system, getting errors on test M5, constantly BSODing, underclocking the RAM to even 2000 still gives errors. Did he put the memory sticks in the correct memory slots? Also, what memory sticks? Is it normal that the P-core E-core frequency goes down to 3.6 gigahertz sometimes for Prime 95? Probably. I don't really use Prime 95 myself very much. Oh, what best way to find out what die memory kit you have? If you have a Corsair memory kit, you have version numbers on them. You can like try to look up the version number. If you have G-Skill, the more like for a few years now, G-Skill actually puts like you can figure out um, what die you have from the like there's a number on the memory stick label. You can figure out what version you have from that, or like what die you have from that. And I don't remember the identification codes off the top of my head. Um, and then for other manufacturers, I don't know. I usually go by timings. Well, at least for DDR5, you can generally just go off of timings. Like, if it's, say, 6030-36, it's definitely not Micron, right? If it's like 6400 CL3239, also not Micron. For DDR4, though, things get a lot more complicated because you have bins like, say, 3600 CL18, which is just everything. Like, really everything. You can get Samsung C die, D die, B die, Hynix CJR, DJR, Micron, Rev E, Rev B, maybe even. Well, 16 gigabit Rev B easily will do 3618. Have you done manual memory timing, HBM timings? No. Because I never figured out how to do that. I know there's the like utility that's supposed to let you tweak memory timings on AMD cards in OS, but that utility, like, well, I never got it to work. Like, I never figured out how to get it to actually like apply to 3D settings. It's Team Group T-Force Vulcan Alpha 32 gig 5600. Well, that is very odd that that doesn't work. Which other stress test do you use? I usually use Y-Cruncher as a stress test. And then, well, yeah, mainly Y-Cruncher these days. Okay, 1720 runs. I need certain driver versions for the tool with the graphical interface. Oh. Yeah, I might have to, the command prompt tool, more version. Okay, I've never seen the command prompt tool. I've only seen the graphical one, and I couldn't figure out how to get that, like, that one, like, I just couldn't figure out how to get it to work. For RDNA2 for VRAM clock, it's all about VDD, CIM, VDD, or the Wattman voltage still has no impact. So when I still had a working 6900 XT, the only thing that, like, the memory just, like, I didn't find anything that made any difference to the memory overclocking. I even tried physically modifying some of the, like, voltage rails that you don't get access to in the software. And yeah, that didn't make any difference. Is Intel XTU a nightmare to work with? Yeah, I don't like it. That's why you don't see me using it. I generally dislike most OS level tuning utilities, especially for CPUs. Because if I remember correctly, I tried raising the memory voltage to like 1.45 or something. That didn't do anything. There's some minor voltage rail on the board that I tried adjusting. That didn't do anything. Um, yeah, because like the Elmore EVC2 actually gives you access to like all of the different voltage or like most of the power rails. And I tried messing with basically everything, and the only thing that I found that really helped the card was run like more vCore makes it clock higher. The core. The memory didn't care. Um, have you done anything with laptop SODIMMs? No. G, you mean GDDRX or GDDR5X or what's GDDR5W? Oh, well, I've never heard of it, so I don't know what it is. But if you can get like pinouts for GDDR5 quite easily. But I think the bigger issue would be like you'd probably have to implement custom timings. Like if you're thinking like if it's the same pinout as GDDR5, you're still gonna have like timing compatibility issues. Um, 8150. Let's try 1770. Okay, so this seems to have a better core than my Sapphire card. Worse memory though. Though that might just be because the memory controller is getting absolutely smashed. Oh, it's double density GDDR5. Oh, I would assume that it is uh pinout compatible. But yeah, you're gonna have to figure out something to do. It's not double density. It's what do you mean by stacked? Like two dies on top of each other, and then. But I'm gonna assume it's just spits out the same. Like it just like I'm assuming it's like dual rank, but for GDDR5. I'm gonna have to look this up. GDDR5. Okay, looking up GDDR5W is like not working. Yeah, because it just like I'm trying to search it and it's just pulling up regular GDDR5, which that's not what I'm looking. This is awful. Man, this card keeps running. It makes zero sense. Yeah, I literally can't find it. Oh, GDDR6W. Okay, that chip package is not GDDR6. That is nowhere near being pin compatible. Yeah, that's not, you're not putting that on a board. That, like, you're not putting that on a GDDR6 board. If the photo in the Tom's hardware article is what it actually looks like, that ain't going on a board. That does, like, for GDDR6. Number of system level. Oh, it's 512 bits. Right, that's 500 and, oh my god, that's a monster BGA for a memory chip. Oh wait, that's for his 8-chip setup. I can't read. But if that and I see no reason for their package like their example image to not be reflective of what it actually looks like. And if it looks like that, yeah, that's not pin compatible. GDDR6 is like four rows per like the solder, like the, I think it's like 4 or 5 rows of solder balls. It's not that monstrosity. Man, the core on this thing seems pretty damn good. Now, if only it worked on the damn Apex. Wait, no, that's the wrong benchmark. No. No. Damn it, why is system info so slow? Any interest in messing with a BC250? I don't even know what that is. Salvage, oh, PS5 silicon. Nah. Magic jumper. What, you think the extra core clock is because of the jumper? I don't think so. I think this just got lucky silicon. Wait, does this even have an ASIC quality? It doesn't have an ASIC quality readout, which, honestly, good thing. Because the ASIC quality readout on AMD GPUs is, like, actually useless in my experience. But honestly, if juicing VDDCI led to higher core clocks, that would actually be kind of a cool thing. As, like, a tweak for Vega. But that doesn't really make sense to me. Yeah, if you want to know what's going on, like, go to the very beginning of the stream and watch it at 2x playback speed. There's this whole section of the stream where I'm struggling to get this card to boot up because of stupid Intel motherboard things. Hence why we are no longer on the stupid Intel motherboard. But yeah, this is a Vega that got sent to me with just a plethora of hardware faults. And, well, last I checked, there was a short circuit on the memory controller power rail. So you might be wondering, how is it running? And, well, that's because there's a jumper from vCore to the memory controller power rail. Because in my infinite wisdom, I was like, okay, the memory controller power rail has a very, very low resistance. There is no way there's a decent chance that there's no way the stock memory controller VRM is going to power it. And I know it won't because it didn't turn on, right? Like, so if the single phase memory controller VRM can't power the memory controller because the, connection, there's a short somewhere on that connection, the 12-phase vCore VRM can probably power the memory controller instead. That wasn't actually my intention, but as it turns out, that's exactly what's happening right now. Any videos planned on overclocking the 8500G? What's the core configuration on that chip? Because I know there's like a single core. Oh, so that's 6, and it has, wait, is it like two power, like, does this have like 2 P cores and 4 garbage cores, or like, what is it? Because I know there's like some asymmetrical ones, and I definitely want whichever one is eligible for single core globals on hardware bot. And if there's a dual core, then I want that too. No, wait, that's just a straight up 6 core. Nothing wacky. Wait, is it? Wait, it has E cores. P cores. How many P cores? 2 plus 4. Oh, it is a dual core! Oh my god! Oh, so it is eligible for... Wait. Wait, why is it showing up only as a 6 core, though? It has P cores and E cores. Also, this just keeps running. I mean, the score's not going up, so... Sussy boost thing's going on over there, but... Let's try that. I guess it's probably just writing the power limit. Yeah, it's really not... I mean, it's occasionally boosting to 780. Right, like if we go max... Actually, apparently it hit 1834. Right, yeah, because AMD's boost algorithm on these cards is quite fun. It goes over whatever you set. $8,500G should be locked? What? But, like, ECLK exists, or is that not... Oh, I guess that's not enabled right now. I think C cores will be far better than E cores. Yeah, so... Man, these are, like, I swear the rules around Intel E-cores for hardware bot were just made up for Intel. Because it's like, it makes, like, you can't, like, because now it's like, oh, but the locked CPUs, you can't, like, how does that make any sense? Like, this, I hate, like, this is one thing I generally hate, is just rules with weird exceptions. I hate it in freaking languages. Like the Czech language has like a whole special list of special words that are spelled like that have very specific spelling. That makes absolutely no difference to how they're pronounced. Like they're literally like in spoken word, you can't tell which version of the word you're saying unless there's context around it. But when you're writing it, you have to spell it correctly. Like there's a difference in spelling. Even though which spelling is correct is ultimately dependent on the context around the word, because the people who design, like, because the people who came up with the rules for the Czech language were insane, and so they made a bunch of rules and then they made a bunch of exceptions to them. And I hate that kind of thing. Everywhere. If you have rules, they shouldn't have exceptions. So if Intel can disable E-cores on the K chips, you can disable the E-cores on all of the chips. And if the E-cores are watered down Zen, or watered down or not, like, they're E-cores. I demand E-core equality. None of this like, oh yeah, you can disable the E-cores on your K-SKU because if you couldn't, your K-SKU would have to compete with Threadrippers, and that would be really awkward. And Sapphire Rapids, I guess. Hello, 3D Mark? Core on this thing seems quite solid. Half the size and have lower clocks. Other than that, they appear to be the same. Yeah, I know. But, like, their clock, like, you know... Like, this is the whole issue with making special rules for special cores. Either all cores are equal, or they're not all equal. Like, either all cores are equal, or, all weird cores are weird cores and can be disabled. Like as soon as the CPU has like some crappier cores on it, you should be allowed to disable them, or you should never be allowed to disable them. You can't have both. Yeah, like I understood that like the cores being smaller but implementing the same functionality is where the clock reduction comes from. Like it's how Vega, right? Like a lot of people might be like, so Vega has the same like stream processor count as a Fiji. It has basically the same performance per clock as a Fiji. Why does Vega have so many more transistors than a Fiji? And it's like, well, does a Fiji do 1.7 gigahertz? No. That's why. Those extra transistors are for the extra gigahertz. I mean megahertz. It's not a literal gigahertz faster. It's like 50% faster clockwise. So non-K Intel CPUs can't disable the E-cores? No, it's for like hardware bot that you can't disable the E-cores apparently. Which is just like silly hardware bot rules. Like that makes no sense. Like I guess I guess from like the like I guess the idea is like, oh, we don't want the old irrelevant single core CPUs getting like pushed out of their rankings or whatever, but like everything else gets pushed out every year. Right? Because there's like a single core like there are single core world records in on Hardware Bot. Yeah, like Lumi has a Geekbench 3 multi-core record with a Xeon L3014. Which is a single core Xeon CPU that, as far as I know, is actually kind of ridiculously rare. And so I kind of understand that it would be, a bit like frustrating for a lot of people who have these like L3014 scores and Sempron 145 and 150 scores to just get absolutely demolished by like an 8300G or something, or some locked Pentium from Intel because you can disable the E-cores. But like, if you have an 8-core CPU, you have to go up against a 14900K. Like, and if you have like a 16-core CPU, your 5950X got surpassed by the 7950X, right? As well as like the 12900K. And then there's just like, yeah, but you can't disable E-cores on whatever because it would like screw up, I guess, single core rankings. And it's just like core ratios don't mean E-cores to me. Thing is 7950X 3D having one CCD locked to 1 gigahertz, clocked 1 gigahertz to less. Core ratios don't mean E-cores to me. But the cores literally are physically different. They have different transistors. Like the Zen 4C is like, you can put twice as many cores in the same space. How is that not an E-core? Because now it's like, oh no, Intel E-cores are E-cores. Everybody else's E-cores are not E-cores. Which is just insanity. Same IPC, same cache. Yeah, but they're physically different. No, it's not just less cache. Like, they're different transistors. This is like saying Vega and Fiji are the same thing. Because they have the same stream processor count. Or like Zen 1 and Zen 2, Zen Plus. Zen 1 and Zen Plus are the same thing because like one of them, like they're the same. Actually, those are more the same thing. Or I get, actually, you could even go as far as going like Ivy Bridge and Sandy Bridge are the same because they're like the same chip, but like different transistor size. Actually, there is an actual IPC difference between Ivy Bridge and Sandy Bridge, whereas Zen and Zen Plus are literally the same, just different transistors. Or like the RX 590 is also an RX 580. Or actually RX 480, 580. Like, no. Like, you either have all cores are equal, or any transistor configuration difference is different cores. So, and honestly, I would actually just subscribe to the philosophy of all cores are E-cores, and the 14900K should not be considered an 8-core CPU under any circumstances, unless you can consider literally everything with more than 8 cores an 8-core CPU. And or you could, you know, what else you could do? You could just make the freaking rankings based on threads instead of cores, and then whichever CPU, like. Because like. Because this is just like I don't like when you have a system where you have basically arbitrary rules that don't make any sense. And I'm not even like, because and under my system where it's based on thread count, and it's not the CPU's thread count, it's the benchmark's thread count. The 12900K would dominate everything from like or like not 12900K. The 14900K would take everything that's less than a 24 thread benchmark basically. Because it just like it's the best single-threaded CPU, it's the best dual-threaded CPU, it's the best triple-threaded CPU, it's the best 4-thread CPU, it's the best 5-thread CPU, it's the best 6-thread CPU, best 7-thread, 8-thread. You get the idea, right? For any thread count short of a until you hit like 16 threads, at which point it would get rolled by the 7950X because the restriction wouldn't be the CPU has to be like it would be the benchmark runs on 16 threads. What's the best score you can get? Instead of the current situation where the benchmark runs on however many cores it can load on whatever CPU you have. So you'd have a ranking of like, instead of like 16 core Cinebench, where you have a bunch of 16 core CPUs with hyperthreading and SMT, you'd have 16 threads Cinebench, and the winner of that would probably be the 7950X. Actually, I'm not sure. Because a 14900K without hyperthreading and the E-cores might actually be very competitive with that. Maybe. Anyway, so I think the multi-core rules are just stupid. The way they're currently implemented. Like, it just doesn't, like, there's no logical justification for why they are the way they are, other than like, oh, we'd feel bad for all the overpriced Intel CPUs. core, just don't need core. Nah, I wouldn't do that. Like, I like the fact that there's a lot of different categories, because it gives you an excuse to bench hardware that is otherwise irrelevant, right? Because to me, it's more interesting to bench more different hardware than to just bin a million whatevers. Um, And so I would go with like, no, you do it by thread count. Like you run 16 thread Cinebench, and whatever CPU you can find that like destroys that configuration of the benchmark, you run that instead of the current situation, because that's even more realistic for actual software, right? Because like realistically, if you're trying to run some kind of application, you're gonna like if you're running a game that uses 4 threads, you use like, it doesn't matter how many cores your bloody CPU has, the game uses 4 threads. So the thread count restriction makes more sense from the software side than the hardware side. And admittedly, it's a bit weird to like restrict Cinebench to a specific number of threads, but like it could potentially encourage tuning of because you can run some very silly clocks on Intel CPUs if you like disable the most of the CPU. Like you can probably run like 4 threads of Cinebench at like 6.1 gigahertz on the P cores, or maybe even higher if you just turn off everything else. No, it's not ARM. Um, I mean, Intel's is not ARM. The only benchmark that doesn't run well on 192 threads was 7-zip and Geekbench 6, though. So, like, what? Um, and R11.5. I mean, you can literally set how many threads Cinebench runs on manually. Like, it would make the software side of it a lot more synthetic, because it's not like we have a good, like, we don't, like, yeah, HardwareBot really doesn't have a very good, like, realistic benchmark suite. But from, like, a real-world use case, it makes more sense to test, like, fastest CPU for 4-threaded workloads than it makes sense to test fastest quad core, and then you have all of these exceptions of like, oh, you can't turn off P cores, but you can turn off E cores, but not if those E cores are AMD E cores, because AMD's E cores are like not E core enough or whatever. Which like it's just like it's insanity. And honestly, like instead of coming up with wacky new rules, I would just say all cores are equal, and E cores get like 14900K is a 24 core. It can only compete in 24 core rankings, because like that's how it worked until Intel came along with E cores, and suddenly we have a new system for ranking CPUs with E cores. Like nobody, there was no consideration when AMD made like garbage freaking, what was it? What did they call it? The cluster multi-threading blunder that is the FX CPUs. They didn't get a special exception of like, oh, actually the FX 8350 gets to be ranked as a quad core because it runs like a quad core. Do Intel E-cores have L3 cache? Yes, they do. Well, they have access to the L3 cache the rest of the CPU does, right? Because the L3 cache is unified for all of the cores. Nah, if AMD comes up with some super wacky... No, you'd have to have like Zen 4 with Zen 3 combined. But then that would just fall under the regular E-core ruling, wouldn't it? Any hints for Asus Vega 64 that crashes with non-stock settings? Minus 10... That's super weird. I've literally never ran into that, so I don't know what you do about that. Sound advice for a cheap upgrade on AM4, get either 5700X3D, 5800X3D, or 5700G. I think you can get like a garbage tier like backup GPU off eBay for like 10, 20 quid. So I don't see a point in having an iGPU as a backup GPU. Especially when you're going to be paying more for it and you're going to be sacrificing CPU performance for it. Now, 5700X versus 5700X3D, 5800X3D depends on if you're primarily gaming. If you're and also kind of what games you're playing, but the 5700X3D is a very solid CPU, so I don't know. Kind of a hard one for me. Man, this thing keeps running. Anyway, my thoughts on the like a lot of the because like I understand the like wanting to have historic like categories still be relevant, and it's like, yeah, then just make historic categories. Make a free for all, like have a free for all, like have some free for all categories where it's just whatever CPU happens to be best at this gets to be best. No rules whatsoever about how many cores you do or don't have. Um, and then it's just like, and you have like the software thread count restrictions. Um, and then on the other end, you have like some kind of historic categories to make historic hardware relevant. Because like, it doesn't make sense to me that we have like arbitrary restrictions on which CPUs can and can't disable cores. Because they are arbitrary. Like, what is the justification for Intel E cores are not core enough that you can't that you can disable them? And like I like benching old junk, right? I mean, mostly GPUs, but Like, I honestly, I would have thought, like, if there was like a historic fire strike, like historic fire strike rankings where it's like you have to use hardware, like you can't just cheese your way to the top of it with like an overpowered modern CPU for your ancient graphics card, but you have to actually run like period correct CPU with period correct GPU. I think that would be sick. That would be freaking awesome, right? Instead of the current situation where it's like, oh, you want to bench hold GPUs, you better have a 14900K or a 7950. Well, actually you can get away with like a 14700K, 13900K. Like you have a few options, but they're all very expensive. And then for and it's just like, so like if it was like, yeah, there's like period correct hardware categories, I think that would be sick. If we want to preserve like old hardware benching, beyond just what you have in the hardware points system. But this current situation of like global points, just like, yeah, Intel CPUs can disable their E-cores, but the AMD ones can't. It's just like, I'm sorry, what? Do you work at Intel? How many 14900Ks have you been sent in the last year? Because it is completely arbitrary. Like I don't. Because I remember reading the discussion about this, about the E-cores and like disabling it, and already my reaction was like, no, this is stupid. Like it's not really like it is just stupid. It allows you to have Intel CPUs that basically have twice as many global rankings as any other CPU. Because you buy a AMD 16 core, and it's only a 16, and it can only compete in 16 core benchmarks. But you buy an Intel 16 core, and you can be in the 16 core rankings and the 8 core rankings. Why? Why is that allowed? It should only be one. You shouldn't, like, every other CPU is stuck in whatever category it like exists in, and then you have Intel CPUs which get to have two categories because what? But the 24 core globals are impossible to get good scores in. Yeah, only because Sapphire Rapids exists. Until Sapphire Rapids came along, Intel was perfectly competitive in 24 core globals. And if the issue is like, okay, so 14900K isn't competitive in 24 core globals, then it should have just always been ranked as an 8 core. Like, this is my issue. It's either an 8 core or a 24 core. It can't be both. And if it can be both, then every CPU where some of the cores are nerfed in some way gets to be both. Which does mean that, yes, the 7950X3D should be also an 8 core. Because, like, technically you have, like, two complete... Actually, they're not even completely different cores. There's, like, one of the CCDs just has more cache. So, actually, like... Yeah, like, I don't see... Like, if the cores are the same, like, how much cache you attach to a specific core, I don't think should affect what type of core it is. So I actually wouldn't support the 7950 X3D getting to go into 8 core categories just because you can turn off the X3D part. That I think would also be like that would, yeah, that would basically be worse than the current Intel E-core situation. But like with the current, but when the cores are they take up less space on the silicon. They are different silicon. There's literally less transistors in them. They aren't the same damn cores. I don't care if they clock lower. Core clock is a direct result of how many transistors you put into the chip, right? Like, high clocks require extra transistors. This is a known fact. And then it's like, yeah, but E-cores are like worse clock for clock, and it's like, okay, so and like, so if AMD use those transistors, like, so now, like, you're starting to get into mighty detailed specifics about what the transistors are being used to do. It's like, oh, if you use the transistors for extra core clock, yeah, that's like one thing. But if you use those transistors for extra performance per clock, that's a different thing. And it's just like, what? Like, these are completely arbitrary, just like restrictions at that point. Also, actually, if the 14900K was always a 8 core, then the 8500G should always be a dual core. Because, yeah. So, man, how is this card still working? This is amazing. I'm actually gonna have to take this thing apart, remove the jumper, and check if that short circuit is still there. Because, like, I don't get it. They weren't locked, but, like, we have plenty of other locked CPUs in the rankings. 14900K not being 8P always is that there are a lot of beginners that would submit wrong every day. Um, okay, then it can't be an 8 core. Like, I actually don't care. Like, the 14900K would still be incredibly competitive for a bunch of 3D benching and single core benchmarks. So, like, biasing, like, I don't see because ultimately, one way or another, regardless of how you, like, set up the ranking system, you're going to be biasing it towards, like, a species. Like, you're basically tuning the restrictions towards a certain CPU. And right now, the ranking system really favors the 14900K. And it's just like, but why does it really favor the 14900K? Like, why doesn't it really favor the 7950X? Or the Threadrippers? Or, like, some arbitrary CPU? Or why doesn't the ranking system, like, favor $200 CPUs? Why does it favor a $600+ Intel chip? Intel seems to show interest in the XOC community. I guess. But, like, unless, like, but the thing is, like, I think if you're, like, so my view on, like, getting more people into competitive benching is that you really need to drop the price barrier rather than, like, um, than, like, well, really anything else. So, like, if I was, like, I would basically prioritize, like, biasing towards cheaper hardware instead of, like, whoever is the biggest sponsor or whatever. Right? Because it's like, yeah, so it's cool that Intel is, like, supportive of extreme overclocking or whatever, but, like, for a lot of people who want to get into competitive benching, it's like you want to bench your Vega, right? The top score for the RX Vega right now is with a 14900K running 6.2 gigahertz for TimesFly, or 6.1 gigahertz, something like that. So you have this, like, card that goes for like $150 on eBay, that requires a $650 CPU to be competitive. And it's on water cooling. It's not even on liquid nitrogen. Right? And also, this would not be affected by the 14900K getting kicked out of the 8-core rankings. So you have a lot of, like, basically the thing that annoys me is, like, you have a lot of, like, cost-optimized budget builds that are grossly uncompetitive on hardware bot because the GPU rankings are dominated by high-end Intel CPUs, and the CPU rankings are dominated by high-end Intel CPUs. Funny how that works. Also, the CPU rankings are generally like, because for whatever reason, people tend to run LN2 more on CPUs than they do it on GPUs. So the CPU rankings, even on low-end CPUs, are like really expensive if you want to get into the top end of the like scores. And CPU benchmarks, in my opinion, are significantly less fun to run than GPU benchmarks. So yeah, I've just always found that as like just not been a fan of how the entire like scoring system is sort of set up. GPU benching is way harder. Is the 14900K AP not cheaper than a 7960X? Yeah, but nobody has a 7960X. Like, sure, you as somebody who gets CPUs from like Asus, but like, look at hardware bot rankings and tell me how many 7960Xs you see, or even like 3960Xs, which at this point aren't even insanely expensive anymore. Like, that's the thing is, like, once the HEDT CPUs, because, like, the last time HEDT was really relevant was when you could get a 5930K, actually, the 5820K, for, like, $300. And since then, HEDT has been basically not a thing. There's 4 people with this CPU. 4. The, like... And if we look at other, like, high-end Threadrippers, there's not even 50 of these. Like, this thing's been out for ages and ages and ages. There's 43 of these. Wait. Yeah, 43 of these. On like hardware bot. So it's like I don't see what the problem would be with just lumping the 14900K into the same rankings as a CPU that 4 people have. All right, because this is 24-core Cinebench, right? Yeah. Oh, we also have the W2495X. But even then, like, you can still get a lot of points on a 13900K on LN2. And I don't think that's going to change for quite a while. But anyway, like, I don't really care that much. I just think it's kind of dumb. And like I really think because the thing with like getting people into benching is like you don't want to, well, and especially CPU benchmarks are so freaking boring. And the worst part is like, okay, you want to get into competitive benching on a 14900K, you can't even cool it with an AIO. Like you can't bench Cinebench on a 14900K on anything less than a massively expensive custom loop because the chip runs so damn hot. So like even the people who build like like your typical overpriced gaming build, so 14900K, 4090, they're not going to be competitive on the 14900K rankings because they're on they're going to be on like a 360 millimeter AIO, and it's going to get completely overwhelmed running Cinebench. Can I just turn up the speed to 6? No, that'll probably require more adjustment. You'll probably have to loosen out the primary timings, unless they're very loose already. Scale's good with memory. 2990WX has terrible memory though. Yeah, thick 360. But the problem with the custom, I'm not saying custom loops are actually particularly expensive. The issue is they're not something a lot of people want to do. Right? Because my like road from I build gaming computer to I got really into overclocking was like I built a system with a 3960X, i7, and a 240 millimeter AIO. And already on the setup, like I was able to bench, I think like 4.8. And it was actually getting like pretty solid scores. And the thing that I realized was like the main limiting factor to my scores was like I can't cool, like I couldn't cool higher voltages than that. Than what I could run for 4.8, because I think 4.8 Cinebench would just about run at like 1.4-ish. Yeah, that sounds right, 1.4-ish. And so eventually I was like, okay, I'm going to go and build a custom loop for this thing. And eventually I got around to benching that CPU at like 5.3 at like incredibly sketchy voltages. Now, obviously, I was doing this with very expensive hardware, but like I started with a system like I could already do a lot of overclocking with the thing that I like started with, and then I wanted more. Whereas right now, it's like you can't overclock a 14900K on anything short of a custom loop because it just thermal throttles all the damn time, unless you turn off most of the cores. Okay, let's finally try 1800. I've been working up to this moment for a while. That is very high. Very, very high. I mean, well, unstable at stock sometimes. Yep, a Mora radiator. Couldn't you just go to eBay and buy a bunch of cheap 360s? Like, for whatever reason, like, used water cooling parts admittedly, some of them can be quite disgusting because people will, like, if you leave water cooling parts with the water sitting in them, they'll, like, the inside, like, especially, like, the copper stuff, it'll just go green. And that's not very fun to clean. But, and custom loop costs €750, and you can get a massive GPU upgrade for that. Yeah, like, but that's once you get into benching, right? Like the gateway, like before you get into benching, you don't prioritize cooling before like gaming performance. And then when you get into benching, it's like, you know what? I don't need a faster GPU. I need a bigger cooler for my existing GPU, right? Um, and that's the thing is like, yeah. So yeah, I know how to clean like copper parts. It's not particularly difficult. You just need a acid of some kind, like vinegar. Um, Coke takes forever in my experience. It's really slow to deal with corrosion. Wish water blocks were more reusable. Yeah, I'm really sad that like universal GPU blocks have basically died. And I'm even more upset that EK is now designing like uh CPU blocks that are motherboard specific. Um like or like socket specific, right? Like you've seen the new EK blocks where the mounting hardware is like, man, I get why, because it's like, oh, it's very clean and aesthetic. You don't see the mounting hardware, and I mean, I've never understood the appeal of black rectangle, but you know, a lot of people like the simplicity of black rectangle. Um, but yeah, it makes me quite upset when I see a water block where it's like, oh, this only fits Intel sockets, and it only fits LGA 1700 sockets, and that's when I'm like, are you serious? Like, what? This thing is $200 and you can't figure out how to make it connect to like different motherboards? This thing benches 1800? What? Dude, the core on this thing is insane. The score didn't really change, but okay, let's try 18. Okay, no, we're staying at 1800 and I'm just going to bump this to 1750. Wait, is it even reaching that P state? I guess we'll find out when I set it to like 1900 and it still runs. Also, I find it really weird how like hardware bot to me at least feels really like CPU biased, which is so weird. Cause like from like cause at least as far as I know, usually the like pipeline into becoming an overclocker is being a gamer, and gamers care about FPS. And get this, GPUs draw frames. You know, like most of them, most of the time. And so it's just been really strange to me how like hardware bot hasn't really done anything about like trying to appeal to, you know, popular GPUs instead of just like 4090s basically. Um and well, the biggest issue I think is that like when you have say a 3060 or something, right? I'm not sure. I bet this is already the case. Um I bet the top score for a 3060 uses a grossly inappropriate CPU. Oh my god, 3060s. I forgot about NVIDIA. What is this? NVIDIA, what the hell? How many 3060s? What? Why is there so many of these? Why do they all have the same name? Did you run out of numbers? Like, seriously, you have the 3060 GA104, the GA106 3584 shaders 128-bit bus. There's a 192-bit bus. What? They make 192... Like, aren't 3060s 8 gigs? No, they're 12 gigs, right? Oh, so that's the 8 gig 3060. Then you have the 3584 shaders, 3840 shaders, but on GA106... Then you have the laptop version, because why the hell not, man? Like, you ran out of 3060s? NVIDIA, get some help. This is not okay. You can't have this many damn 3060s. Okay. Yeah. This is a balanced system. A 13700K with a 3060. This is a realistic gaming build. This is a realistic CPU for somebody with a 3060 to own. And of course there's like, wait, how many? They're like, oh, and the GA106 version is just completely dead. So yeah, there's like no 3060 subs. Even though I'm gonna look this up. I'm pretty sure on Steam Hardware Survey the 3060 like outsold all of the AMD GPUs. So like, TimeSpy one is okay. Oh, I guess TimeSpy would be more popular. Oh, yeah, this is a 5800X. Oh, it's a good thing the GPU doesn't spit out much more than 10,000 points, because... But the other thing is, like, it's weird how few 3060s there are, because... Go to the hardware survey, and we go... Literally 3060, most popular. How many 3060s do you see on Hardware Bot? Basically none. 1650. And like, admittedly, none of the modern GPUs are particularly overclockable. But... Oh, we've got Tractor and his 12900K, of course. And he's in TimeSpy as a... Yep, this is definitely an appropriate motherboard and CPU. Well, motherboard, yes. Yeah, the motherboard's not too ridiculous. Wait. I might be biased. The 1650 is like a $150 GPU. This is like a $200 motherboard. Yeah, we've got all the usual suspects. Now, to be fair, like, honestly, I do this kind of thing as well. Like, I recently bought a 7790. I'm gonna feel... I guess I could use a 3600 to not make myself a complete, just absolute... Yeah, I guess I could use my 3600. Because the 7790 is very, very fun. Like, this card on air cooling, you can do crazy clocks. Like, 1354 is actually kind of low, in my opinion. Yeah, you have, like, 1450 on air cooling. 1475 on water. And these things come at a gigahertz stock. So yeah, I guess I'll run it with a 3600 when I decide to bench it instead of bringing something more OP. But then, of course, you get to something like, oh, I don't know. I'm assuming that's a pretty popular GPU as well. Oh no, there's the 3060 laptop, 1060, 2060, 3060 Ti. 3070 is pretty popular. You go to Firestrike, and oh look, 13900 KS with a 3070. And if we go to Time Spy, I imagine it's just as bad. Now, to be fair, at least this one is on... Yeah, the GPU is on LN2. Man, I wasn't sure what I was looking at, but that's a CPU pot on top of the GPU. That's brave. That's really brave. Wait, does this even have mounting art? It's just sitting there. Oh man, that is brave. Like, that thing's... If that thing moves, like if that LN2 pot tips, and, like, without the card moving with it, under load, that card is, like, instantly dead, probably. Yeah, if you pull the heatsink off a GPU and it's running an actual workload, in my experience, that tends to kill the GPU. Very, very quickly. Okay, so you know what? I respect running, like, you run a 3070 on LN2, and I actually don't care what CPU you use, but you run it on water cooling, and you bring a 6.2 gigahertz 13900K to... Though, admittedly, that actually is really pushing that 3070. Yeah, but this is the issue. Like, here you have a... Was it, like, not running right, or what? Oh, no, yeah, this guy just had, like, potato CPU, so... Yeah, see? Higher GPU score, but, oh, you didn't buy the latest and greatest Intel CPU? Get screwed. Even if you ran the GPU on liquid nitrogen. Admittedly, this is an old score, isn't it? And, yeah, it's a pretty old score. But even then, like, this is... HardwareBot has an Intel bias. Oh, I guess we could have also checked the 1060, because that's, like, a crazy popular card. But I already know how the 1060 rankings look. Oh, no, the 1060. Okay, the 60 series NVIDIA cards are actually just cursed. Like, look at this. What even is this? 1060 mobile, GP104, 106, 160-bit, 5 gigs of memory, GDDR5X, JP104, but 6 gigs of memory, JP106, but 6 gigs of memory, GTX 1060, Max Q. Like, NVIDIA, what is this? $7950X would be enough too? That's like a $500 CPU though. Like, that's the whole issue, is, like, you're not going to put a 3070 into a system with a 7950X. You're going to put a 3070 in a system with, like, a 7700. Right? And if you want to bench your... Like, if you're a gamer and you're like, oh, I'm going to run something like 3D Mark, Time Spy, or whatever, for... I guess technically the, like, ray trace 3D Marks are free of the CPU affecting it. But the ray trace 3D Marks are, well... Are they popular? I don't really have many GPUs that support ray tracing, so I wouldn't know. Yeah, but the ray trace 3D Marks are not very popular. Is the 2060 as cursed as the 1060? Oh, yes. Yeah, no, so the 60 series is just generally cursed. It's just like this, the like 60 class and NVIDIA, I bet that's why those are so high up on the survey, is because I bet all the different flavors of, like, 3060 are actually just one card. The 2060 is the least cursed of the 60s so far. How bad was the 660? Was there a point in time when the 60 wasn't insane? Okay, yeah, that's actually... It's not too bad, is it? What about the 760? Could be worse. 560? Yeah, so 560, you also have quite a few different flavors, but it's nowhere near as bad as the modern 60s. Now, honestly, 2060s probably have some decent headroom on them, don't they? I'm assuming the TU-106 is the more common one. And, oh, look, 13900 KF. Why am I not surprised? Then, of course, we have, 9980XE in Firestrike Ultra. So this is actually very GPU biased. So, yeah, but, like, custom water at 2250. This is actually wouldn't be insane. Like, you could throw together, like, a cheapo AliExpress loop or something. And like, try to compete with this. Or, like, a cheapo eBay loop. Actually, 2060, you could... Does the 2060 have, like, the insanely wide hole spacing that the rest of the 20 series had? Because, like, I'm wondering, like, could you just, like, strap a CPU block to it? Because those are generally cheaper on eBay. You can get, like, old EK blocks for, like, $20. Oh, yeah, you have some, like, you have these holes, like, all the way out there. Oh, it's a rectangle. Yeah, but you could strap a CPU block to this. Man, that chip is huge. 20 series dies are monstrous. Like, absolutely monstrous. The 2080 Ti is just absolutely just a beast of a chip. I wish I had a 2080 Ti. Actually, that reminds me. Anyway, I'll have to deal with that after the stream. Yeah, like, look at this thing. I'm pretty sure this is actually the biggest GPU ever. To, like, at least for consumers. Data center, I'm sure there's bigger ones. But for consumer applications, this is the biggest GPU. And then Time Spy, we've got, a 12900K at the top. And at least the GPU was on liquid nitrogen. 2300. Oh, I guess there's no volt mods on the card or something. Because that's, like, surprisingly low. Okay, so yeah, like, the 2060 just doesn't really get a lot of attention, apparently. For, like, really pushing it. GTX 2080 were larger? What, the chip? I really doubt that. The TU-102 is absolutely gigantic. This is just 576 millimeters. That's really not that big. The 2080 Ti is 754 millimeters. And this thing is 815. Okay, so this is bigger. Doesn't look bigger, does it, at a glance? Oh, it is very slightly bigger. Yeah, like, relative to the PCIe slot, the die is slightly bigger. So the TV is the biggest one. But the 280 is, like, nowhere near. Like, 576 millimeters is actually quite tame for a high-end GPU. 470 on the 285. 480 was 529. The 680 was actually really small. Yeah, that was 294. Absolutely tiny compared to what you get after, like, for the high end. And then you get, like, 780 Ti was 561. 980 Ti was also really big, because that was still the same manufacturing process. So that was 601. Wait, wasn't the Fury X? Oh, the Fury X was slightly denser. Well, no, slightly smaller. I think it had like more transistors. Yeah, way more transistors. It's like almost 10% more transistors, but smaller. Um, Vega's actually kind of adorable. Oh no, they're onto me. Thanks to the new innovations in AI, however, I can sort through those boat identification algorithms just fine. Anyway, so yeah, Vega's not that big. It's just 495. Um, and then you get like, and then the 20 series is just absolutely like, even the 2080 is 545 millimeters. Absolute chungus chips. And then you get like 3070 Ti and it's back down to like 400 millimeters. 3080 Ti is like 628. So actually 30, like the GA102 is big. 4090 is actually 609. So actually that's reasonable size for Nvidia. Yeah, it's a bit smaller, but it's not like tiny or anything, whereas the 480 is tiny. The 4080 is tiny. That's 379. Yeah. It's actually really small. Anyway, the Vega has still not died by some miracle. I don't get it. Like, man, I really wish I had like my ideal with the camera setup to just like take you over to the work area, and the work area wasn't like an A4 sheet of paper. It's actually smaller than that. Like if my work, like I wish the like soldering workspace was like larger, so we could just like take the card apart on stream, and I wouldn't have to like faff around with the camera and stuff, and the microphone. Actually, the microphone is the worst part because like I do actually have a wireless microphone, but it needs like batteries and so like I've sort of switched over to the wired mic, and I like the wired mic. It's very convenient. Also, it's like not attached to me, so. Yeah, anyway, what did I want to check? Right, time spy. Because the thing I've been wondering about is like this GPU score, okay, it's not actually that high. Is it that high compared to my own scores? It is. Yeah, the core on this thing is insane. Or is, wait. Oh, wait, we're not on the, well, we'll see. We'll just keep pushing. So we've still got like a ways to go before this is actually like massive scores, but let's try 1777. Yeah, because the thing is, the other card I ran that on the, I think, liquid BIOS. Doesn't have the metal border. I don't really care that much. Run Furmark. Oh, hell no. The only thing Furmark is good for is, like, stress testing power delivery components. What, the stiffener? Have you selected the min frequency in the drivers? That's what I'm adjusting with the, like, multiple, P-states clocks that I'm messing with. Is the load too much to hit P7? I'm not sure. I think it might be. Or, like, the Okay, so it finally crashed. Hard. Very hard. Mean to fail a power delivery stress test. I mean, I don't really think it would because we do have the like stock power limit on the card, but like I don't see a point in testing firmware on this thing. Like I don't care about finding out like if firmware does nothing, then it's like okay. And if firmware breaks it, then like well that's annoying. Right? So it's like what is there to gain from running firmware for me? Hopefully the drivers didn't implode, because that's a thing that happens with some AMD driver versions, is if you crash too hard, the performance just like dies, and there's nothing you can do about it. Nope, it's not volt modded. It just has a short circuit on the VDDCI rail, and in order to power the memory controller, there's a jumper from the vCore VRM to the VDDCI rail, which is worse than if it was volt modded. Way worse. That's why it says sketchily repaired. No, VDDCI usually is the memory controller, not the HBM. The HBM is fine. The HBM power delivery is fine. The memory controller normally runs on 0.95 volts. Now it's running at like 1.15. I don't actually know what exact voltage it's at because I don't have the oscilloscope hooked up. I did consider hooking up the oscilloscope, but lazy. Also, I didn't think the card would live this long. I was really expecting it to just die. Well, like, it just kind of keeps running. Oh, it's not little. It's a red devil Vega. It's very big. Or at least the heat's actually it is generally very big because like the PCB is like bigger than the reference PCB. The heatsink is also very big. Like it's a big Vega. I'm trying to come up with a good analogy for like powering the memory controller with vCore. I guess it's like imagine if I'm trying to think I actually can't think of a good analogy for this. Like at all. Because it's like nah, I'm trying to come up with an analogy just because analogies are fun, not because like there's some deeper meaning to it or like deeper purpose to it. But like I'm trying to like yeah, I can't come up with one. Evidently the memory controller is very robust though because like it's been running on vCore for the last 2-ish hours and it's still here and like working. More ample. So the thing is, there's a 0.2 ohm short on the VDDCI rail. That's why it's running off a V-core. Because the original voltage regulator literally was tripping short circuit protection. Like, it wouldn't even try to turn on, if I remember correctly. Or, well, actually, I didn't check if it would try to turn on. Because I thought it, like, shorted out the original voltage regulator, but it didn't. Wait, what made the... Anyway, this card is super cursed. I'm just gonna run it off of V-core, I think. Or will I? I'm not sure. I might do something about this. The ample might be enough. I mean, it's worth trying, I guess. Like, if I move the jumper, like, I want to move the jumper to the back of the card anyway. So, when I do that, I guess I could also ample it. Right? Because I can just put the ample on the back of the card and see if that, like, if the ample can run it. And if it can, then I guess I'll just permanently attach the ample to it. Why no music? Cause we're gonna try a no music stream for once. Mostly because earlier in the stream everything like went to hell, and then, and yeah, like I just sort of decided not to go with music, so. Okay, it's not scoring very well, but whatever. Okay, let's try 1722 on P state 5. Honestly, I am still so surprised that this thing keeps running. Nah, I didn't get flagged or anything. Oh, I guess I should have put up this. Yeah, because it's like we're just gonna basically, like, for the most part, we're just gonna be watching Time Spy. I'm not actually seriously benching the card because, like, it's not gonna, like, well, there's no point trying to push it with a 5700X 3D because in Time Spy, the top score requires a Intel CPU. How much power is it pulling? It's reporting 330 watts in the software. So probably like 350 to 380 IRL. Maybe more than that. I haven't done anything to like remove the 50% power restriction. Right? Like you can mod the registry to set the power limit to like 200 watts or something. I haven't done that. I mean 200%, not 200 watts, but like yeah. I haven't done that yet. There's not much point doing it when, you know, like for Time Spy it's just not going to be competitive because of the CPU score. But evidently, I should so I'm pretty sure you can actually run like dual Vegas for some benchmarks. I think just Time Spy. Yeah, you can run 2 Vegas in Time Spy. And it does actually boost the score. So it is actually working. And I think when I first booted this card, it was on a 7950X. So, I mean, I'm going to feel kind of bad for doing this. Because the current top score for dual Vegas is with a 5800X 3D. And I'm seriously considering just kind of rolling up with the 7950X. Nah, that's lame. Also, how old is this score? Oh, that's actually from 2023. I guess I could try to beat it with the 5700X. You know, it really wouldn't be that difficult to stick the other Vega into the system. Like, this motherboard that I'm on, like, one of my favorite features of this motherboard is the fact that it does support 2 GPUs. The main issue is heat sinks. Yeah, I'm not sure how I'm going to cool it when I do that. I want to test this. Well, I'm not sure how it's going to work out in terms of cooling, but there's a second Vega in there. So my idea was like, I'm just going to ram the air down between the cards and hope for the best. Like, I just want to see if this, like how fiddly is this to even, like, enable? Because I've literally never run multi-Vega. Okay, so we're in Windows. Do we see both cards? Yes, we do. I think the drivers are, like, detecting the second card. Go away. Tuning. I want to... Wait, how do I reset everything? Reset. Okay, well, the driver sees 2. Wait. Just say linked discrete. Okay. It's gaming. Global. Enhanced sync disabled. Oh, wait, these have crossfire? Okay, we kill the frame tracing. Wait, you can... Do these do fire strike? Because if these run fire strike and crossfire, I've Christmas came early. Oh my god, they do. Wait, I already ran multi-GPU Vega in the past. I thought they only did Time Spy because of, like, DX12 hackery, but no, these actually support crossfire. Today is a good day. A very good day. Anyway, I need to turn off all the AMD trash that they put in their new drivers now. And I guess we'll start with Time Spy just because. Oh, right, we have the ultra low power state running on one of the cards. Okay, yeah, there's like a registry thing that you need to do to disable that. That's fine. I can deal with that later. Because the main concern I have is that one of these cards has only really one fan directly. Actually, one of these cards, like, they both... Cooling right now is highly compromised. So I'm really wondering how this is going to work out in terms of temperatures. Max. Yeah, off of just like a single Time Spy run, I'm really wondering what kind of temperatures we're going to get, because this cooling setup is far from ideal. An Afterburner ULPS is just one click. Yeah, I know. Actually, no, it requires a system restart. Well, that's fun. I might have to reinstall the drivers. Wait, can you bench Vantage on these? Yes. I might try running Vantage Extreme on them. Not today, but with like the a CPU appropriate for globals. But yeah, we might have to reinstall the drivers. Oh wait, this one's. Oh wait, you're right. This one's on the liquid BIOS. It has dual BIOS, right? I might have to restart again. Fun. Multi-GPU is a good idea. Oh, great. Wait, what? Why is the primary one now asleep? Oh, you gotta be kidding me. Okay, settings. That might be enough. The wallpaper doesn't, like, the settings, like, it's a mix of timings and voltages, and where they are is actually kind of random. Like, they're kind of grouped together, but there's no, like, deep, there's not a lot of, like, deep thought on why one is where it is. Why they, or, like, why they are where they are. You paint flames on the motherboard VRM heatsink? Yes, I did. I have considered filling them in, but in my experience, that doesn't tend to go very well. Oh, wait, the power color one is, like, asleep now. Why is the power color one asleep? Okay, we're reinstalling the drivers. What? The flames are coming from the CPU. They're not upside down. I mean, they're upside down because, like, the postcode is in the, like, the camera framing is for the postcode to be in the top left corner of the stream. But IRL, like, they are coming from the CPU, which I think is the correct place for them to be coming from. Paint them red. No, if I'm going to paint them, they're going to be orange. Also, I picked up, so I actually mentioned this earlier, I picked up a 7790. This is the most ridiculous 7790 I've ever seen. It comes with a backplate. It's a 7790. This is like a $150 graphics card or something? A backplate. Also, that backplate has a random heatsink in it. Oh, you can't see it. Yeah, but there's a heatsink, just like, yeah, anyway. Which is really wacky. I don't know why it's there. Oh, and also what I find really funny is this card has 2 heat pipes that are thicker than the 2 heat pipes Gigabyte put on the GTX 760 that I picked up recently. Or, I say recently, it was like several weeks ago. But I did end up picking up another 760, and yeah, like, Gigabyte's WindForce 760 has like 2 6mm heat pipes on it. Whereas this 7790 has like 2 8mm heat pipes, which is just like... That Gigabyte 760 is just like the weirdest, or it's not really weird, but like that heatsink is just, it makes zero sense. It has 3 fans and 2 heat pipes. If your heatsink has more fans than heat pipes, more fans than heat pipes, you did not make a good heatsink. Is it one of those insulation backplates? No, it's metal. Like, it's a full-on metal backplate. The shroud, the fan shroud for the card is plastic, but the backplate, that's metal. Wacky card. Motherboard, no, so the motherboard has plasti dip on it because I ran it on LN2. And the plasti dip is orange because I like the color orange. Okay, so we're back in Windows. Time to install drivers. Where are they? That's 23.9, 22.5. Okay, I think this is better. AMD does a really good job of making all of their software look like all of their like UI look really fancy, and then it's just like actually using it is like oof. Anyway, I guess I could consider this Vega fixed. Which is just insane to me. It has a short circuit on VDDCI. It literally made a popping noise while running Firestrike. Actually, this really doesn't make any difference with my system because it's not connected to the internet, but... A fanless Gigabyte GT7600 that just had a giant block. Yeah, but that's old GPUs. But the 760, like Gigabyte, by the time Gigabyte made the 760, they knew how to make heat sinks, okay? They were capable of producing perfectly good heat sinks. And for whatever reason, that card does not have one. right? Because that card, so that 760 that I picked up is based off of this 770 in a lot of ways. So, like, it has this PCB, literally this PCB, but this phase is missing, this phase is missing. These extra low side MOSFETs, yeah, those are all missing. There's only one low side MOSFET in the 6 phases that are still on the card instead of 2 low side MOSFETs. On the back of the card, these capacitors are missing. This is missing. That is missing. That is missing. These are missing. I think this one's also missing. And like, so it's like, it's this PCB, but like heavily down costed. And you might think, oh, but they kept the heatsink, right? Like, this looks like a good heatsink. You've got your copper base plate, you got your bunch of heat pipes, like, good heatsink. And then there's what Gigabyte actually put on that 760. Which I'm not even sure if Tech Power Up has got sent. Yeah, so they didn't get a sent. Did they do that also on the... So they had a better heatsink. They had this 3 heat pipe thing, and these heat pipes are like 8mm heat pipes. And then there's the heatsink that like my card came with. Because the thing is, like, this 760 is actually on like a... It's not exactly a reference NVIDIA PCB, but it's pretty close to reference. Like, it's very close. Well, okay, no, it's actually a reference GTX 680 PCB, but like fully populated. Typically, the 680 PCB only had a 4-phase, not like they didn't bother with the 5th one because, yeah. I'm trying to find a photo of the actual heatsink because you can see like this. You can see that there's only 2 heat pipes here, right? But I wanted to show you how ridiculous it looks from the other side. And it did not occur to me to take a photo. Actually, maybe it did occur to me to take a photo. Did I take a photo? Let's see. I have not taken any photos of this card, apparently. Interesting. Anyway. Yeah, so it only has 2 6mm heat pipes, which is just like, what the hell? Like, it's... No, it's even worse than this. Like, this has the heat pipes extending in both ends. Like, that heatsink is awful. Like, it's the cheapest heatsink I've ever seen, like, in its design. Like... Actually, I'm not... No, I've seen downcosted, like, I've seen a 7870 XT, which uses, like, the heatsink off of a 7970, but it's been, like, downcosted heavily. And, like, the manufacturer of that 7870 XT couldn't even be bothered to match the thermal pad placements for the memory chips to the location of the memory chips. They literally just took the... Like, they took the memory heatsink from a 7970 with the thermal pads in position for a 7970, and they just slapped that over the top of the memory chips on a 7870 XT. Those memory chips don't line up. Like, at all. But at least the heatsink on that thing got downgraded from, like, 4 heat pipes to 3. But then Gigabyte went like, yeah, so we took our GTX 770 heatsink, and we downgraded it from like 5 heat pipes to 2. Yeah, 5 heat pipes. Man, that's so the 770 heatsink is like really nice. The PCB is actually quite nice, and then there's the 760 version, which is just like, what are you doing, Gigabyte? I wonder if maybe they used it on the 660. No, they didn't. I don't think they used that design of shroud on 660s. Yeah, no, they didn't. They did this. What does this look like? Even this has more heat pipes. This is actually a better heatsink. My plan is to like dig through my like I have a collection of like heat sinks from like dead GPUs. I'm sure I can find something that'll fit. Or at least I'm hoping I can find something that'll fit. Because I don't really like having cards as loose PCBs. Anyway, our AMD driver is apparently installed, so let's restart. Oh yeah, I absolutely love the look of the old WindForce cards. The 700 series to like 900 series NVIDIA. Not older than that. Actually, no, so I specifically don't like the like very smooth ones. Right? So like uh I don't like wait, what? They didn't get a 7970? Did they get a 7950 then? 680? Capture card is being extremely cooperative. Oh, so yeah, I don't like this heatsink. Like I don't like how this looks. Like the glossy plastic is just like, But yeah, the ones that they had right after that, those are cool. Anyway, so we are back in Windows. We have drivers. We have. Think I need to check that like we're on actually like stock BIOSes because the liquid BIOS actually won't run on the Nitro card stably. Okay, we're both are at stock. Goody. Good. And go away. Why are the drivers freaking like they're on par with like freaking ads on away with you? Where is the freaking like remove all AMD stuff? Off. No more. Seriously, it's like those pop-up ads on websites where it's like you're a driver, leave me alone. You're not gaming mouse software. I guess we can leave the issue detection alone. Performance. Anyway, we're not going to touch anything over here. I just need temperature monitoring, so we need GPU-Z for that. Oh, and I need to kill ULPS probably. Let's try it without killing ULPS first and see how it goes. And if it like does the blue screen again, then we'll kill ULPS. Yeah, because I'm really wondering how this is going to work. Because, like, I don't have, like, fans mashed right against the fin stacks, but the fin stacks are really big. And so I'm, like, wondering, like, does just, like, basically just, like, does, like, turbulencing the air around the fin stacks enough to cool these? At least at stock? Oh my god, so many FPS! Man, if only multi GPU worked in games like it does in synthetics. Nah, this is way more than plus 50%. This is like doubling the frame rate. It's like I think it's like 80% more FPS than the card with than one card with an overclock. Also, so the thing about moving the like VDDCI to VCore jumper to the back of the card though is that I kind of really like the idea of like keeping all of my modifications like as well, depends on the modification. Like sometimes I'll like go ham on a card and just go like I want the biggest capacitors, not because they actually do anything, just because they're big and they look ridiculous. Um, or I shouldn't say they don't do anything. They do like they don't do like a 10 millimeter diameter capacitor does not do much, like isn't like electrically better than a 6.3 millimeter diameter capacitor. They have the same effect in terms of like voltage regulation. But when you put a 10 millimeter diameter capacitor on a card, it's a lot more obvious because it's really big. So it's like some cards I tried to make them look clean and you know like collected and not like just Frankenstein's monster, and then other cards I just go like I want this to look like well Frankenstein's monster. So the biggest caps, and I don't well that's actually kind of most of it is biggest caps. Because the like you don't really want to have like a mess of wires everywhere because then you end up with a card where it's like you can't even pick it up because you know you try to grab it and you like get snagged on a wire and you rip some component off the board, which no fun. So this cooling setup is working way better than I think it should be. It maxed out at 70 degrees. 71 degrees. And yeah, it like almost doubled the score. Really far away from taking like first place for two-way Vega. I keep pushing it? Yeah, sure, let's keep pushing it. Though this stream is now going kind of way further than I ever wanted it to go. So I guess we need to kill ULPS. Oh no, the AMD driver's gone yellow again. Why? Also, where's the fix for this? Oh, I forgot. Oh, I forgot to turn off the frame pacing. That gives you extra performance at the cost of stutter. Uh... Uh... Well, that fixes it, I guess. Thanks, AMD. Very cool. Some very nice driver software you got there. I don't know why it does that. It just does that. It's not night mode. It's very much the AMD drivers. I've tried figuring this out before. It's definitely the AMD drivers doing it. Anyway, so ULPS is gone. Wait, how does overdriven tool? Oh, it just handles them as two separate cards. Cool. So I'm pretty sure both of these cards should be able to run 1100 on the mem. Or like 1120. So we're just going to go straight for that. You know, I might end up overclocking the 5700X. Well, okay, not overclocking the 5700X 3D, but overclocking the memory for it, because Time Spy is like super memory bound. And the top score is on a 5800X 3D. And I honestly don't like. I think like with a slight memory overclock, I might be able to catch up. Especially like if I manage to get more GPU score, then just like throwing some more. Throwing some more. We're just gonna set that one to max. Throwing some more like CPU score at it would help. Anyway, so we're gonna go 1120. Okay, actually, I'm not gonna go straight to 11. Let's go 1100. One GPU 0, GPU 1. There's apparently no synchronization option, which is quite frustrating. Timing level 2 on both of them. One of these has like really garbage silicon, so... Oh, I guess I didn't max the power target, so we need to do that. $14,900K, I can get 5.8 all-core static with V-core of 1.34. To do 5.9, I need 1.44. Yeah, no, that's normal. At some point on modern CPUs, you will basically, the next increase in frequency will just require an insane increase in voltage. Because it's not linear. Wait, they're both set to the... Oh, whatever. That's also, like, one of the main reasons why I don't really... Like, I don't really care much about how something clocks at low voltage. I care how it clocks at high voltage. Because you do occasionally get chips where it's like, oh man, at like 1.1 volts, this is amazing. It does massive gigahertz. And then you try to run it at 1.3 and it's terrible. Or at 1.4 and it's just terrible. Because it like stops scaling completely before other chips do. Honestly, like 5.8 at 1.34 is really good. What are you testing that with? Cinebench or like... Oh boy, my electricity bill. It just occurred to me, I'm probably running like 700 watts worth of GPU right now. Actually, no, it's not that bad. It's been really warm in the UK recently, so I've not had to put the heating on as much. Actually, like right now, it's not even on. And yesterday it wasn't on. Common UK electricity L, yes. The GPUs are probably pulling like 10 times the power that the CPU is pulling, considering this is a 5700X3D. Oh, at the wall, I'm pretty sure I'm pulling over 800 watts. Easy. I don't have the power meter hooked up to this power supply, but actually, nah, I don't feel like dealing with that. Like, I could take the cable all the way over the desk and like, the desk is enough of a like um disaster as is. We don't need the freaking like super thick 1600 watt power supply cables trying to get across it as well. So what did the temperatures max out at? Because like the cooling setup here, oh, 100 and oh wait, that's both the same card. Damn it. Why am I dumb? 16K. Wait, I think I'm outscoring the current top score already for GPU. Oh wait, nope, 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 nope. Yeah, they're running way higher core clocks, which cooling wise, I am not even close right now. No, this is on the blower cards. Man, that must have been so loud. Do you want to be in a room with this run? I don't. I don't want to be anywhere near that. Actually, you could wear earplugs. Um, yeah, they're running like 1710 core, which I am not doing that with this cooling. I don't think. Um, yeah, like this. I need to figure out how to like. I guess maybe like taping the heat like fin stack off so that like the air is more forced in. But I don't think I'm moving enough air. I think ideally I'd actually want to run the cards on risers so that I can just strap fans to each of them individually. This is one thing I've all like kind of like this is an idea I've toyed with is like buying a mining rack just for like multi GPU benching on air because then you could just run like full size like fat 16x risers and then you like it doesn't matter how big the GPU heatsink is, right? Like you can just run every card on a Morpheus or something. Get some dry ice. So I actually don't have enough LN2 pots to run 2 Vegas on dry ice. So that wouldn't help, unfortunately. Because, yeah, that was my immediate thought was like, oh, just run them cold. And it's like, oh, but I need another GPU pot, and I don't have one. And GPU pots are very expensive. Wait, why is this one reading out 0C? Like, it's not supposed to be in ULPS. Oh, well, back to overdriven tool we go. I mean, I guess I can try, like, 1700, 1655. Like, worst case scenario is it's just gonna crash. Right, like... Wait, this thing really sucks, though. Oh, well, maybe if it's running as the secondary, it might be fine. We'll see. Worst case scenario, it just blue screens. 4X 290X OEM. Definitely need earplugs. Are these tools something everyone can get from the internet? Overdriven tool? Yeah, you should be able to get that on the internet. Yeah, you can actually get Overdriven tool on SourceForge, which is pretty cool. And there's a release on GitHub. Wait, is there... If it's on GitHub, is there source code for it? Doesn't look like it. Oh, well. Oh, right, if it's on SourceForge, then... Oh, right, yeah, there is a source on SourceForge. It's in, like, 7-zip file format. And it's in C++, so that is not helping. I can't deal with that. Man, reverse engineering somebody else's timing decoder was such a chore for me. Took me so very long. And also, the way my decoder works is awful. It's so bad. It does work, though, and it also encodes the timings. Actually, if I stream the 7790, we'll probably use that. I'll probably use it. It does work, yeah. And it's way nicer to use. Like, the code behind it, atrocity. Absolute just abomination. Don't even ask me to explain how it works, because I don't understand it. Like, you can see how the tool, because there's like in the, because like I left, like, because it's I just made it in Java, because most of my programming experience is Java. So I wrote it in Java. But anyway, and for the UI, I just use Java Swing UI, because that's a really convenient way of building a UI in Java. Because if you use NetBeans, you just get like a GUI for building GUIs, and it's like, okay, I'm just going to use that because like, too much of a pleb to do anything more complicated than that. But okay, so the card with the actual fan like sitting on the heatsink, that one's actually running kind of okay. Hey, I beat them on the GPU score. Barely. I wish we had frequency readouts for card number 2. Yeah, but card number 1 is not having a good time temperature-wise. Maybe I could, like, squeeze, like, zip tie some little fans to the heatsink? Actually, no, I think if I put the original shroud back on, because I haven't put the shroud back onto the Red Devil card, because I wasn't sure if it was going to work, right? So it's like, why reassemble the card fully if I don't even know if it's going to survive? It's just going to be more of a pain to take it apart later. But yeah, so I actually beat them on GPU score by a couple points, so that's cool. Anyway, where was I going? So anyway, so yeah, I put the UI together with Java Swing, and there's a tab in the tool that was literally like, it's like a debug tab for me to see the decoding process. Cause like, I figured out what the input is. Like, I knew what the input is supposed to be, and I knew what the output, like, well, I control the input, right? So I have a fixed input, I have a fixed output. So there's a tab that basically shows the like inner workings of the decoding. So that I could keep, like, so basically I could figure out what is going on. So, yeah. But it does work, and it decodes timings, and it encodes timings, and it's, like, yeah. So if you want to, like, make completely custom memory timing straps for your, everything older than, like, it works for GDDR cards. So like it should support, yeah, it should support the 5700 XT. I've not tested that because I think the tool that I reverse engineered the decoding from works with a 5700 XT. So if the thing that I'm stealing the decoding from works with a 5700 XT, then mine better work with a 5700 XT. And it also works for, like, it definitely works for, like, HD 7970. So it works like 7000 series. I don't think it works for 6000 series. It definitely doesn't work for 5000 series. Because, yeah, I think I tried copying a 5000 series strap into it, and it just spits out gibberish. But yeah, so when I do the 7790, I'll probably use that because, like, especially for Firestrike, the combined test is so sensitive to memory performance for some reason, like GPU memory performance, not CPU memory. Actually, I'm not sure about CPU memory. It doesn't really care about CPU memory performance, but GPU memory performance, it cares a ton. And so if you change the timing strap, it makes a huge difference to the combined score. And especially on a lot of really slow cards, the combined score is like the biggest bottleneck in the entire, like, for the entire benchmark. Your biggest bottleneck is the combined score. So, yeah. Anyway, I guess I could try push it further, like 1150 on the memory. I don't think the HBM is gonna, like, the HBM temps I think are fine. Yeah, 73. That's fine. I guess I could also open a window. It's the weekend, so there isn't exactly a ton of traffic, so that's nice. 3D Mark website record is 16784 graphics score. Okay, I'm definitely not reaching that. The hardware bot record is like 253. So I already beat that one for GPU. Not overall, because they have a much higher CPU score than I do, though I think with a memory overclock and maybe a bit of BCLK or curve optimizer, maybe both, I might be able to catch up. I know it's Sunday. That's why there's no traffic. If it wasn't Sunday, there'd be well, I mean, if it wasn't like a weekend, then there'd be so much traffic. In previous video, you were using load line saturation on an MSI Z790i MPG board. I have no idea what the setting does to VCore. Can you please explain? Basically, it allows the motherboard to use like a very low yeah, so at low loads, you get like a very low V droop. And at high load, it'll actually transition to your whatever LLC setting that you set. Oh, we're getting some artifacting, so I guess the HBM isn't thrilled about the temperatures it's running at. I wonder how hard it would be to design like a daughter board that would like split, that had like a PLX chip and it would split into like X8, X8, X8. And also had like massive spacing between the PCIe slots, so you could just run the biggest heat sinks. Anyway, so with the load line saturation, I think, oh, I can't, it was too long ago, I don't remember. But it is actually a really cool feature, because it means you can have like a very, like you can use the very high V-droop settings, and you don't need to have like crazy high idle voltage. Isn't level 1 Tech's working on that? Well, on a PCIe splitter board? KP had that. Yeah, but like, I mean, like, that was for PCIe 2.0, not like 3.0. Oh no, it crashed. That's interesting. I'm pretty sure individually each of these cards can run in 1150 HBM, no problem. Max temp isn't any higher than last time. I don't think with the 50... No, I just need more GPU cooling, and I don't really feel like figuring out how to do that on stream. RX 580 goes max 1.212 when I have the voltage on 1.1. What are you measuring it with, and what are you setting it with? There are PLX boards. Yeah, I know there are. And some of these brakes are gonna drive me insane. Man, or if I had higher higher... Oh yeah, higher RPM fans would also probably do the trick. Because right now I'm just using some like Corsair maglevs, and I like them. Like they go up to 2400 RPM. I've had them for ages. As far as like being a brute force airflow fan, like as far as being a brute force fan goes, they work pretty good. But like, I think for this application, maybe a bunch of like Arctic P12 Maxes would be better. Because those go to like 3,000, don't they? Might do a better job of like cramming the air down the side of the heatsink. Or like I'm thinking like maybe ducting the air into the heatsink somehow. Oh, they go to 3,300 RPM. Yeah. They are loud. At 2,400 RPM, I have not seen a fan that isn't loud. Good core on a 290X on air cooling. If you can bench 1,200, it's good. If you can like finish Fire Strike at 1,200 core or higher, it's good. Yeah, evidently I need more cooling. Because this is no worky anymore. Okay, so I think I might be done with this stream for today. Yeah, because it's been 4 hours. I also streamed Burnout Paradise on Twitch like at like 4 a.m. or something like that. Anyway, I'm kind of wondering like what benchmark options there are for two-way Vega. So there's Fire Strike Extreme. These all get decent points. Man, 56. I mean, I'm off the top of my head, I want to say a single 6900 XT can do that. So yeah, so there's Fire Strike. I don't know that I'd bother with. I guess I'll do the GPU test on its own, just because it's like an actual pure GPU benchmark. What were these? Wait, these are water cooled. Oh, okay, no, one of them is water cooled, the other one is air cooled. Man, I wish my nitro wasn't so garbage. The core is so bad. I was kind of hoping that one of these would be like big points, but yeah, I'm not seeing that. Like even Time Spy is only 15 points. I guess there's not very many people running like dual Vegas. Yeah, there's only 22 for the 22 for the Time Spy rankings. For Fire Strike, I'm guessing it's going to be like probably the same actually. No, it's worse. It's 16. Yeah. Extreme then? What about Ultra? $11. Yeah, so they're like nobody benches dual Vega. Actually, you know what? I don't feel like it'll be it's not a proper AHOC live stream if I don't run Fire Strike at least once. So we're going Fire Strike. Now, usually Fire Strike should be lighter than Time Spy, but I'm not sure with Vega. Which flavor should we run? Should we run the 4K version? Yeah, let's try the 4K version. No, well, no, the thing is, I like seeing silly high frame rates. So we're going to do the 1080p version. Because the best flavor of Fire Strike is the 300 FPS version of Fire Strike. Yeah, the ROG Strix 5700 XT had the issue of Asus didn't figure out how to attach the heatsink. The heatsink is good, but like if you have it in a typical like horizontal orientation, like typical case orientation, the weight of the heatsink is so like the heatsink is so heavy, and the mounting hardware that Asus gave it is too soft, so the heatsink actually pulls away from the core, and it runs really hot. If you run it on a test, like horizontal test bench, so the heatsink isn't getting pulled down by gravity as much, it actually runs at perfectly good temperatures. So yeah, Asus fails to attach a heatsink to an AMD GPU again, because funnily enough, Asus has had issues with that for a very long time. Like there was 7970s where they had heatsink contact issues. I actually 4 gigahertz 5700X3D. Do you think it'll be a CPU bottleneck? Just put the card upside down. Yeah, that'll make it. That should make it run just fine. Well, we're not hitting 3. Oh, there was a brief blip of 300. Oh, I need to turn off tessellation. I forgot about that. Buy a riser cable. It's a riser cable, as in S. Because it, like, rises the card. A riser cable would be a racing inspired. Wait, what was it? Racing inspired car. What? Riser cable. Yeah, no, it's fine. I just found the riser cable funny. Because of, like, ricer cars. So, what would a ricer cable be? GPU drivers are using? 23 something. Racing inspired car enhancement. Yeah, enhancement. I don't think it's enhancements though, because the whole point of a car being riced out is that you have a bunch of silly modifications that are inspired by race cars, but don't actually do anything. I'm gonna look it up. Define race-inspired cosmetic enhancements. Yes. So it's because it's just rice on its own. It's not right like the R is not part of the actual like abbreviation. Yeah. So your ricer cable would have a wing. PCIe 1X RGB USB cable. Yes. With a wing. It must have a wing. I don't know where you'd put it on a cable, but it's gotta... No, it would have the most ridiculous... You know the PCIe... Oh, no, because it's a right... So you have the latch, right, on the other end of the riser cable, because one end goes into the motherboard. There's no latch on that. It just has the hook that, like, latches to the board. And the other end, you have the PCIe slot with its own latch. So that latch would just be the most, like, biggest, most ridiculous latch you've ever seen. There, wing. Well, yeah, it's also a combination of the, like, rice cars being specifically Japanese, like, well, import cars, which are probably Japanese. What was it that I wanted to do? Oh, right, kill the tessellation. And now we should get the real 300 FPS Firestrike experience. Racer GPU would be single slot? No, it would be absolutely gigantic, and it would be like a 4060. It would be a 4060 with a 4090 heatsink on it. Oh, if you see the voltage, like if your voltage is set to 1.1 and you're seeing 1.12, that's fine. That's just like the voltage regulator isn't perfect. And also the sensors aren't very accurate a lot of the time. But if you set 1.1 volts and you're getting 1.2, that's weird. Loudest fans possible. And coil whine. Just as much as possible. Asus eventually fixed the 5700 XT heatsinks. So it depends if you have like an early model or late model, I think. Anyway, the Firestrike record is 40,000 points. With a 5950X. Oh. Wait, they're not running... they're running with TESS. Why are they running with TESS? Or what? Thoughts on the MSI 4080 Expert? Isn't the heatsink kinda not great? Wait, I want to see my score. Yeah, I need a faster CPU for this one. Okay, and let's try Firestrike Ultra as well. Though, also we'll just check the 4080 quickly. But if I remember correctly, the Super MSI one was, like, not amazing. Heatsink-wise. I actually kind of like what MSI did with the PCB, because they, like, you got a fuse for the memory, which I think is kind of neat. Also, the input filter on this thing is quite substantial, though I don't... I think that might be normal for 4080s. I don't remember off the top of my head. Though, in terms of actual power stages, it's pretty generic 4080 stuff, so nothing special there. But yeah, if I remember correctly, it was like heatsink wasn't particularly... It's not... Yeah, like 35 is... Okay, it's not louder than the Amp Extreme. That's 39 dBA. Oh, and there's also the Gigabyte ones more louder at like... Yeah, but the Gigabyte one's like... on the loud BIOS, the Gigabyte is quite a bit cooler. So yeah, you like... The heatsink's not amazing, but like, other than that, like, I don't see anything wrong with it. Are there no other models that are available? Because, like... In terms of temperatures and noise, like, so you have the... Okay, so the Asus Strix is, like, super cool, super quiet. The Tough is also cooler and quieter. Not as much. The Galax card is cooler, also quieter. Gigabyte is cooler and quieter. The NVIDIA Founders Edition is cooler and the same, same loudness. Though I guess it could vary a little bit card to card, especially the hotspot temperature. I'm not super focused on that because this can, like, sometimes you'll get like a card from the factory where the mounting is really good and sometimes it'll be really bad and the hotspot will be just all over the place because of that. But the edge temperature tends to be quite consistent between like remounts. So yeah. Anyway, so that's my thoughts on the super expert from MSI. Is like, it's not the quietest or the coolest. That's basically it. There's a huge GPU hotspot temp difference, normal on a 17900 XTX. I don't know. I've never used a 17900 XTX. And I've also not really been paying much attention to the reviews of them. I guess we can look that up, though, on Tech Power Up. Oh, boy. Oh, boy, that's screen tearing. Oh, man, you could literally see two different... You can see... Oh, man, they are so out of pace with each other. One of the cards is like 2 frames behind. Oh, my God. Like, you can see the band of, like, a past or future frame, like, moving through. Oh, well, anything for FPS. Like, I could turn the frame pacing back on, but then the FPS would be lower. So, looking at the temperatures on... Actually, wait, I wanna see this absolute, like... Oh, man, we got stutter and tearing. Oh, man. Dude, we had, like, 4 frames in 1 frame. Oh, my God. It's so bad. You know, you would have thought that it would be, like, really bad when it was running at, like, 300 FPS, but nah. It's really bad when it's running slowest. Because that's when you get the biggest difference between the frames. Because, like, here's the thing. If you're at, like, 300 FPS and one of the cards is running slightly ahead, there's not too much of a difference between the output of the 2 cards. But when you're at, like, 40 FPS, and one of the cards is off by a frame, that's, like, a 25 millisecond time difference between the frames. Which means you get absolutely atrocious screen tearing. Anyway, so looking at Tech Power Up, it does look a lot like... wait, no, we've got the combined test. Combined test is going to be... Oh, man. Oh, dude. Yeah, because the frame pacing was way off, right? Like, you had some frames that were, like, literally being... Like, they were rendered at the same time, basically. Oh, my God. It's just disintegrating. You know what's and quad GPU, you can if you get more GPUs, you can make it even worse. It's like it could tear more. Not too far off the record for that one. The record is like 12371. I mean 317. 1178. Like like 500 points is like pretty substantial, but like yeah, not like cuz it's the slow CPU is much less of a problem here than on the other tests. Like Firestrike especially, right? Like when the GPU spits out 50k and your CPU is doing 26, that's not great. Or when the GPU is doing like 13k, then it doesn't really matter that much. That the CPU isn't spitting out 50. Anyway, right, so 7900 XTXs. Yeah, they seemingly do have like pretty substantial hotspot differences, though I think you said 35 or something, which is more than any of these. Yeah, because we've got like 54 to 74, that's 20. 59 to 79, that's 20. 67 to 86, that's like that's 19. That's 27. Right? Yeah, that's 20. No, that's 17. 13? 19. Yeah, so 35 degrees is like if you're at stock, that seems like some kind of heatsink issue. I think 25 degrees like that sounds pretty normal to me, but like 30 degrees plus, that doesn't sound very normal to me. Why abuse the poor card like this? That's not abuse. The card is happily just churning out frames whenever. Like, it's not waiting for no one, you know? It's just rendering them frames, and if that frame is like 5 frames behind the one that's currently on screen, it don't care. It's rendering. It's like coil whine. You might find it really annoying, but the card doesn't have ears. The card don't care. Didn't make a ROG Strix 7900 XTX. Yeah, I guess they didn't. Which kind of makes sense, because, like, they did make a tough. But the thing is, like, with, like, the Strix cards are, like, the tough is already, like, $100 premium. Though they do have a Strix 4080. At the same time, I'm not sure what you would change with this PCB to make a Strix. Like, yeah, you already have the fancy, fully digital monolithic power systems controller. The 70 amp monolithic power systems power stages. And like you've got it's literally like the thing is these are this is basically reference for a 7900 XTX. So it's really like I guess they could have maybe slapped a bigger heatsink on it or something. It's not like was it running particularly hot or something? Yeah. I mean, I think it has more power stages. Maybe. Does it? 17 phase for V-core. 17. Oh, it's the same. So yeah, like, but that's already like a ton of power stages. The tough is a good PCB. Yeah. Looks like they upgraded the filtering a bit. Like Asus upgraded the input filtering a little bit. So that's like something. Mostly over on this side. I'm not sure which 17900 XT I would go for. I mean, XTX. Man, why can't they just keep a sensible naming convention? Like, we had a 6900 XT, and then they're like, oh, now we have the XTX, and it's like, what you think putting another X on it will make it sound more impressive? Like, will make people think that it's faster than a 4090 or something? I bet this is the same. Yep, this is just a reference card. Admittedly, also like upgraded input filter. Also has fuses. Yeah, Sapphire likes to put fuses on their cards, which is pretty cool. Just means that if something does go wrong, it'll be a lot easier to fix. It doesn't prevent failures. It just makes failures a lot easier to repair, potentially. Did ASRock come up with anything interesting? Oh, they added a phase. Just one. And I don't like what's going on over here. Yeah, they added a bunch of optional capacitor pads and then they didn't populate them. Very cool. Right? For like extra input filtering. It's like, so I'm not sure if this actually makes a difference, but like I find it interesting that with the 6900 XT like the input filtering was really not great on the reference card or like the reference like the reference PCBs. Also, I think the Nitro actually comes with the highest power limit of all of the 17900 XTs. I mean XTXs. Yeah, so XFX just like upgraded the input filtering a bit and then actually they upgraded it more than ASRock did. Like we have these extras over here. And these. Oh yeah, this is so I like this. Yeah, so I like the XFX, I like the Sapphire. Not really a fan of the ASRock board unless is the regular Taichi different? Probably not. No, it isn't. Asus board is cool too. Yeah, don't really, but like it's not substantially like I think the biggest difference you have is like the XFX and the Sapphire PCBs, and I think out of them all, the Sapphire PCB has the highest power limit. Isn't there a mention somewhere? Because, like, I think this one offers a, like, 450 watt BIOS. Wait, I think ASRock also put out some kind of insanity BIOS for their cards. Yeah, so we have the Nitro Plus, and that has... Like, that's just 339. That's nothing. Or was it ASRock that put out, like, the absolutely ridiculous... Oh, here's the 400 with a 440 amp current limit. Wait, where'd my BIOS collection go? Oh, there. 339. 400. Okay, so ASRock apparently put out the Insanity BIOS. Wait, what did Asus put on their card? 315. And, 315. Okay, so Asus only put a 315 BIOS. What did Power Color put out? 315. So I guess 315 is like the norm for the 339 from XFX. 327, which is just the most random number I've ever seen. Like, what? Like, 339 again. So I guess it's only 327. Though I'm pretty sure you can slap the 400 watt BIOS on whatever card you like. So, yeah. And I'd probably slap it on the XFX or the Sapphire card. Oh, 339 PPT, 405 total board power. Wait, oh, did I miss that? All right, what's the total board power on this then? Wait, no, that's the 339. This is the 400. Wait, where do you see the 450? Or like... plus 50%? I don't think they allow plus 50% anymore, do they? 339. Like, as far as I know, if you want to, like, take the power limit off of a... off of a 17900 XT, like XTX, as much as possible, you need to, like, use the Elmore EVC2 to skew the power readings. X670E Phantom Gaming Lightning, I think it is a very feature-packed board for the price. 448 amp current limit? Yeah, like that makes sense. Actually, it's kind of weird to see the current limit lower than the power limit, because a lot of modern GPUs can pull, like, run at very low voltages. But yeah. So, I think that'll be it for the stream. The Vega apparently works. Even though there should still be a short circuit on it. Like, I'm definitely going to take the card apart and, like, remove the jumper. You might be wondering, what do you mean, the jumper? Well, I mean, if you missed the beginning of the stream, I mean this. As in this right here. This used to be the VDDCI VRM. Except the card, the card had so many problems. Like, so very many problems. Also, the jumper that's currently on the card is not this, because this wouldn't fit under the heatsink. This is way too tall. So there's like a... basically, I have like some very, like, yeah, I have like some thin wires. They're not that thin, but like, yeah, there's just like a jumper. Like that. So that it fits under the heatsink. Anyway, I might end up moving that to the back of the card. But yeah, this card was like super, super broken. So, this didn't, like, I'm just going to go through all the things that didn't work. This didn't work. This didn't work. this gate was like smashed, as you can see. This was dead, so that got replaced. This didn't work. That didn't work. I mean, that's the controllers for the chips on the front. Oh, this capacitor was broken. Honestly, like by far the most involved GPU repair I've ever done in terms of just like how many different things I had to deal with. Because like I've had other cards that are like technically more skill, like higher skill requirement, like the reballing the memory chips. I'd say that's more difficult. But in terms of like sheer quantity of random broken stuff on a card, this wins. Like the only thing that didn't need any repairs was the VCore VRM. Oh, I guess the 0.65 volt or 0.6 volt rail. There's like another voltage regulator down here. That didn't need anything. HBM was fine. VCore VRM was fine. But then like everything else, like got a smashed gate. This thing's dead. That thing's dead. This is dead. Then the real kicker is like, so after I repaired that VRM, the card, like I tried to run Fire Strike on it to stress test it. I hear a pop and short circuit on VDDCI, which is how it ended up with this jumper. And yeah, this works. Apparently this is fine. You can have a short circuit on VDDCI and you just run VCore into it and it works. Absolutely do not understand how this card is still functional, but it does still work. So yeah. Absolutely. And the card showed up in like really good condition. So I don't know, maybe somebody else tried repairing it before me and there's like side effects of that, but it didn't look like there was any soldering work on there. I think they did I think the smashed AND gate might have been somebody just like investigating the card and then like screwing up during reassembly rather than any actual like random broken, like all the random broken things. I think like, I don't know why they were broken, but they were broken. I still can't believe it works, though. Like, if I pull that jumper off of it and there's still a short circuit on VDDCI, I am, like, how? How does it still run? Like, there are so many other cards where it's like, oh, you know what? It makes me wonder, should I, like, because you occasionally get cards where, like, no, that doesn't work. Like, there are, like, because you'll get, like, I've seen a lot of NVIDIA cards where, like, you'll have a PEX rail that's, like, shorted out. And it's just like, yeah, but the thing is, those don't usually have the volts. Because, yeah, like, I have a lot of NVIDIA cards that have, like, or not a lot, but I have a couple NVIDIA cards. Actually, I think I might have already turned them into parts cards. But, like, I've seen, like, NVIDIA cards where, like, you have a short circuit on the PEX rail. And it's like this is a death sentence. If the short, because like you tried to run the card and it's like like they're just dead. And then I have this Vega and it's like, yeah, there's a short circuit on VDDCI and it's like it works. You just shove VCore into it and it's what? How? Admittedly, I've never tried just shove VCore into the supposedly dead PEX rail before. So I don't know. Maybe you can just burn whatever shorted out with VCore, but it doesn't. That seems like an ill-advised option. That was actually sort of my intent. Was just like, oh, I'll just shove VCore into it, and either the short circuit will just like get vaporized, or it'll work, and it works apparently, which doesn't make any sense to me. But hey, I'm not gonna complain about it working. So. Yeah. That's it for the stream. So thank you for watching. And oh, like, share, subscribe, leave any comments, questions, suggestions, because technically you could be watching the VOD, right? So you could leave comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with the channel, I have a Patreon. There's a link to that down in the description. There's also the HOC Teespring store where there's like shirts and posters and hoodies, you know, YouTuber merch. And I've also got a Bandcamp, which wasn't present on today's stream. The music from the Bandcamp wasn't present on today's stream. Is that it? Oh, I guess I could also point out that I do have a PO box. So if you have like a dead GPU that you want to get rid of, or just an old GPU that you want to get rid of, I'll depending on what it is, I might be very interested. So yeah, more burnout. Maybe. I don't, you know what? I don't want to overdo it. I don't want to like try to stream for like, cause like I feel like I crash afterwards. When I've done like the like 12-hour live stream and then nothing gets done afterwards. So I don't really want to, cause at the time it's always like, oh yeah, I can keep going, and then the next day I wake up and it's like I'm not doing anything today. Nothing will happen. You can't make me. Yeah. Anyway, but I'm not sure what I'm gonna do next with the card. Oh, I guess I should try to figure out why it doesn't boot on the Apex. Because the core does seem to be better than the core on my other Vega, so if I could like bench this on the Apex, I could probably improve my like Vega scores, like single card scores a bit. Actually, if I get it to work on the Apex, we could run both cards on the Apex. And then I could absolutely crush the dual GPU rankings with my very fair and balanced Intel CPU. I have a 780 Ti matrix. Ooh, that's a matrix I don't yet have. Because I have a... Wait, I don't have a 980 matrix either. Don't really want... Do I really? I mean, I wouldn't mind having one. It's not really a priority, though. Anyway, oh, P.O. Box. Send email. All right, I should have mentioned that. I have a buildzoid@gmail.com. Actually, I'm pretty sure my email is on the channel. Because the thing is, I pay for the P.O. Box, so, like, I don't want people sending random stuff without, like, notifying me in advance, because it would get really expensive if it just got, like... And I really don't want somebody sending me, like, a bunch of old LGA 775 boards. I don't know what I'd do with them. 980 gold anniversary? Wait, they made a 980 in gold? Because I have a golden 980 Ti. And a regular 980 Ti matrix. No piles of GT. Please, no GT 710s. I did not know they made a golden 980. I guess I should... So if I'm going to get a 980 matrix, I'm going to look out for that one. You have the SLI bridge too? You can send the SLI bridge. I have many SLI bridges. I don't like... what's one more SLI bridge at this point when I have who knows how many of them? But 8800, that's too old. Basically, if it doesn't support like DirectX 11, it's too old. I think the oldest cards in my collection are HD... Actually, HD 4000 doesn't support DirectX 11, right? Ah... 4850. Oh yeah, those are just DX10. But they can run Vantage, and Vantage is good. So, those get a pass. XFX HD 4851 gig? Isn't that just a reference card? The 4000 series cards I have are really more exceptions than like I'm super interested in 4000 series. Yeah, I'm gonna go with a new. That looks extremely reference. Like I'm specific. Like most of the GPUs I'm going for, like. And also, I should point out my GPU collection at this point is very pretty complete, actually. It's very rare at this point that I see a GPU where I'm like, oh yeah, I really want this in my collection. 7970 VaporX. I have a bunch of those. I have so many VaporX cards. I'm a massive Sapphire fanboy. Not used RX 590. Okay, I might have really really underestimated how many random cards people would want to send me. Anyway, you have the email address. Send me an email. And like, yeah, I'm gonna like not have anywhere to put all of these extra cards. I shouldn't have said that. Oh well. 8800 GT. No, definitely no ancient and like Nvidia anything older than 400 series, no, and AMD anything older than 4000 series. So that makes it really simple to remember. If it starts with something if it's older than the like 4000 or 400, no. 25870s? Oh, I guess, yeah, it also depends where you are. 7950 Windforce. I've been vaguely interested in one of those. Because it's not a... So, funnily enough, the 7950 Windforce is not a reference 7950 PCB. And it also uses a voltage controller that's, like, unique to that card for a 7950. Like, Gigabyte used it on other cards, but they've never... Like, that controller... was never nobody else ever used it on a 7000 series card. Wait, I'm trying to find the PCB. Damn it. Did Tech Power Up never get sampled one of these? No, they did. Yeah, also the PCB's kind of trash now that I look at it. Wait, is it? Because if I'm not mistaken, it should be... give me a second. I shuffled all of my windows around because I was like, oh, I'm going to end the stream. This is going to, like, totally happen, right? Like, when have I ever managed to finish anything when I said I'm finishing it? Yeah, so this PCB. So I've been wondering about it. A little. About this PCB. Because it's like, it's not just another 7970 reference card. And we got a 1, 2... Oh, it's just a 6-phase. And I bet the MOSFETs are garbage too. Are they? Oh, I don't recognize that part number. Wait, nope, these... Oh, these are Renaissance. I don't think these are very good. Yeah, but this voltage controller, you will never see it on any other 7000 series cards. Not even from Gigabyte. Like, they don't use it on a 7870 or anything. It's literally just like 7950 and 7970 that they have this PCB. Which, like... is weird. Also, what is up with this? Why is there so much capacitance on this? That's, like, not standard at all, is it? Yeah, no, that's not normal at all. It's usually just a bunch of multi-layer ceramics and maybe a tantalum. Yeah, what? Why? Because I'm pretty sure, yeah, I'm pretty sure this is like the equivalent. Yeah, okay, so these are this should be 0.95 volts over here, and then this would be, wait, is that 1.8? That doesn't make any sense. It's huge. Like, this is absolutely gigantic. What is that? This is VDDCI. Or at least, yeah, this should be VDDCI. This should be memory. So we have, like, the most... Wait, but this has the lower inductance inductor. I might be getting my 0.95 volts and 1.8 volts mixed up. But anyway, that's really wacky. And then if you look at the back, they actually customize the actual like capacitor configuration directly behind the core, which is like XFX has a card which does something similar. But yeah, you don't see that often. Also, we have this random well, not tantalum, SMD polymer over here. I think that's on memory. Oh, and they have the option to add one over here as well. Yeah, so like, this is a PCB that I'm pretty sure that it's not actually that interesting if I got around to measuring it, but like, I just find these kind of little differences like, oh, it's different. I wonder if it actually matters. Probably doesn't. Especially since AMD GPUs tend to have like a pretty generous amount of V-droop. Compared to NVIDIA cards. Like a lot of modern NVIDIA cards have like no V-droop, so you get quite substantial differences in voltage regulation card to card. But AMD cards usually have quite a bit of V-droop, and that means that like you don't get that, like the VRM doesn't have to like work that hard. 6950 XT though, give it more V-core and more cooling. Oh, yeah, no, I don't think this is a great PCB, but for like a 7950, your options are really limited. Like 7970, you have some amazing PCBs available, right? But for the 7950, the PCB options are much more limited, right? Like 7970, you can get this. Man, I wish MSI put out a motherboard with these golden inductors. Just because, you know, it would look kind of cool. It's literally just like a special paint job. It doesn't do anything, but it looks cool. You also have the matrix, right? With its like 2 rows of V-core VRM because they couldn't fit it. Like if they put it next to it, like if it was in just a straight line, it would be like ridiculously tall. You also have the VaporX PCB, which this is just a, well, actually, so the thing is, this has a ton. Oh, and then we don't have MOSFET pictures. I am upset. Anyway, yeah, but this PCB has like relatively low phase count, but it has 2 low side MOSFETs for each phase, so it actually ends up looking like, from a low side MOSFET count, it's like a 16 phase basically. Or it's, yeah. And that's why phase count is like not really a good way to gauge anything, really. But then you get to like 7950s and your options are just like various, well, you can get the VaporX with the 7 phase, but I think that's actually like the highest phase count PCB you can get on a 7950, because usually with a 7950, oh yeah, you get this thing, which like this. So you might be wondering, like, why is there so much, like, random blobs of solder everywhere? And this is how you make, because the PCB, like, the card has, like, a 150 watt power limit. At least the original 7950, I think, had 150. And so the idea was, like, okay, we're going to run, like, there's not going to be a VRM heatsink on this card. Oh, yeah, it's, like, 175, as you can see. 150 average, or... Oh, no, average is like, yeah, so like the stock 7950 was just like super, super underclocked, basically. These things ran like at 800 megahertz stock. Yeah, so MSI actually overclocked it by 10% out of the box to 880. But the stock spec was 800. And the reason that stock spec is so low is because there's like, well, it's just like super low power limit. And the side effect of that was that you could actually, like this PCB, you can ship it with no VRM heatsink and it runs fine at the stock power limit. If you start like removing the power limit and doing things, then it does end up getting very, 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 very hot. But yeah, so you have all of these like exposed power planes basically to sink more heat, like to sink heat more effectively. And the 7950 is one of the few AMD, one of the few cards where Asus didn't make a custom PCB. Because Asus, like, makes custom PCBs for almost everything, and then the 7950 they didn't, they didn't do a 7770 custom PCB. I actually have a 7950 with this PCB that's, like, really, really good. The core is, like, amazing. Actually, I have a lot of 7950s with this PCB, because this is, like, the default PCB for a 7950. Also, you'll notice that there's not even any, like, screw holes for mounting a VRM heatsink, because it's supposed to run completely heatsinkless, with just, like, airflow from the heatsink. Yeah. Did MSI even have, like, a base plate on this? No, you literally, yeah, like, they're literally just... Wait, that looks a bit like a base plate. I guess that might just be like a... Wait, no, there's a bolt over here, so there is a base plate, right? Yeah, okay, MSI did put a base plate. Not that it has any fins on it. But yeah, so for 7970s, you have, like, lots of options in terms of really good PCBs, and then 7950s, it's just like, nah. Reference. Oh, the old Twin Frozer? Eh. Okay, right. It looks okay, I guess. I'm not a fan of, like... The fans look too small for how big the heatsink is, in my opinion. I think the 7850 version of it was, like, proportion-wise, it just, like, the fans don't look big enough to me. And there was a smaller version of the Twin Frozer. I don't think that's it. Or 7270, that's got, like, one phase? No way. Oh, also you can get some really cool PCBs for 7870s. Actually, you can get 7870s with better PCBs than 7950s quite easily. Also, this is not a Hawk, it's a Power Edition. Yeah, it's actually pretty substantial. Like, yeah, you get a 6-phase on it. Man, this PCB just looks so cheap. I don't even think it's the, like, the brown color. It just, like... Like, just the way it's, like, laid out. Like, they've really packed everything... Yeah. Like, how everything is, like, super packed in. Nah, the crooked components, that I don't care about, but, like... And I think also the fact that you can just see all of the, like, traces on the power delivery, it's like... Yeah, I think it's just how, like, everything's, like, crammed onto the board. That's, like, doing it for me. Also, I think maybe the MOSFETs. Wait, what controller is that? Because that's not a chill. Ugh. I'd rather have this. I mean, this still looks pretty cheap, but, you know, you got actual, like, power stages. And this is a 5-phase. Actually, the MSI might be better in terms of power handling capacity. Not sure, but with this you get the, like, chill 82 this is basically the 5-phase version of the 8-phase controller that you get on the 7970. Anyway. So yeah, I am a massive nerd for old irrelevant graphics cards. Actually, this PCB is the first PCB I ever successfully turned into a e-power. Well, successfully turned. Only 3 of the phases actually run. But it does run, as in, like, I managed to cut the PCB right here, and I just have the VRM, and the VRM actually, like, outputs power. This was the first PCB I ever managed to do that with. Since then, I've managed it also with, like, a 7950 PCB. Actually, no, that might have been a 7970 PCB. So yeah, since then I managed it with quite a few more cards, but this one, like the thing that makes this one super easy is to get this to turn on, you literally just feed, because you have your 5-volt regulator over here, right? So when you cut the card, this is still attached to the VRM, because this is a real, like if you're cutting something like, say, a 7950, okay, not this one, I don't like, but if you're cutting, like, yeah, let's say you cut one of these. Oh, wait, no, I want the reference PCB. So let's say you want to make an e-power out of one of these. Oh boy, this only came with a 4-phase? Anyway, let's say you wanted to make an e-power out of one of these. So if you cut it right here, right, so that you just have the VRM, the problem you're going to run into is that your 5-volt power supply is over here. So you need to, like, move this somewhere over here. And then you need to figure out where to connect that 5-volt power supply so that, like, the things that run on 5 volts on this end of the board actually get 5 volts, which is really fun. And then, of course, you also have, like, 3.3 volts, which normally comes in over here. But you literally just cut the card in this area, so that's not connected anymore. So now you need to find a new place, like either you get, like, a 3.3 volt regulator, or you grab, like, 3.3 volts off of a SATA port or something. Or, actually, if you're attaching an e-power to a card, you can just steal that card's 3.3 volts, right? Like, from the, like, whatever card you're attaching the VRM to, you can steal the 3.3 volts from there. You could also take your 12 volts from there. But anyway, you could take everything from there, actually. It's kind of funny, like, how... Like, this is a realization I had with, like, while making, like, e-powers, is, like, you don't really need to, like, self-contain all of the power supplies for the e-power to the e-power. Because, like, you can't just steal, like, whatever card you're attaching it to has everything the VRM needs anyway. So you could just steal it from the victim, right? Or, well, you can steal it from the target. The victim is the card that's getting cut up so that you can steal its VRM. You might be like, but why would you steal a card's VRM? Well, sometimes you want to overclock a garbage low-end card that comes with, like, a 2-phase. Also, you can, like, steal, like, you know, stealing, like, a 4-phase off of a 7950 isn't really much, but you can also, like, steal, like, an 8-phase VRM or a 12-phase or whatever, like, you know, like, whatever dead card you have, if you want to steal its VRM, like, you can. So, anyway... where was I? Right. So, yeah, old cards. It's for when, like, because the thing is, if you're messing with old cards, like, I'm gonna try find a good example. Okay, no, this... There. So let's say you want to, like, bench a Titan and, like, really bench it. Like, you want to push this thing to the absolute limits. Well, the problem you're going to run into is that this core is very big, and this VRM is not very big. This is a 6-phase. And so if you want to push one of these on, like, liquid nitrogen or something, you're going to basically... And the thing is, like, you wouldn't usually just cut up some random card for that, but... You would end up doing, man, are you... Wait, I went 780, idiot. Are you kidding me? Okay, well, this is a 680 getting E-powered. And the reason you do this is because a lot of the, like, reference, like... You wouldn't do this with, say, a 4090, because the... Well, okay. No, yeah, you wouldn't do this with a 4090, because your life would be extremely difficult. But, like, it used to be that, like, there were certain cards that the only VRM that they came with was garbage. And so when you decided to overclock them, the VRM would just kind of die. So you would so you'd take a better VRM and replace the bad VRM with the better VRM. And this is a terrible way of doing that. And I was really hoping, like, there's some really... There was, like, really good pictures of these cards in the past, and I can't find them. I guess I could also just show one of my own E-powers. So, like, I have a... Oh, also, if you have a card where the VRM blew up, like, really hard, that's another option for E-powering. Let me pull up a example. Because, actually, I made a video E-powering a GTX 970 some time ago. Because the V-Core VRM on it was, like, a garbage 4-phase, and it blew up, because of course it did. And it put a great big hole in the PCB, so pain to fix. Let me find a... I have way too many photos. And searching through them like this is not working. Oh, I had a 1080 where the VRM blew up and E-powered that. But for that I used like a dedicated power board instead of a donor VRM. Where is that GTX 970? Okay, this is way old. Do I not have any pictures of it? No, this is wait, this is way too new. Oh. Found it. Wait. Oh, it didn't blow a hole in the board. But I just didn't want to deal with fixing a garbage 4-phase just so that the garbage 4-phase can die again. Yeah, there was... Was there a video of this thing? I think it might have been a video of a different card. Anyway, yeah, so here you can see a HD 7970 VRM. Yeah. Yeah, this is definitely an HD 7970 VRM attached to a GTX 970. Oh, and it's on the B550 again. I really like this board, if you can't tell. So yeah, this is a DirectCU 2 Asus card. Actually, this might be a... Wait, this isn't a 7970, is it? It only has a 6-pin. Right, that's a 6-pin, right? It's not a 7950, though. What is this? Oh, I think it's a DirectCU 780? I must know. I think it's a 780 VRM. Because, yeah, I had a 780 something. And it, like... Yes. Yes, it is. Yep. Yeah, because I had a 780 that got sent to me with, like, a massive crack in the PCB. And at the, like, I never... Well, basically, I couldn't get the card to work reliably. And what... Well, I solved the issue of the card not booting, but I was still left with this issue of, like, there was just, like, memory artifacting. Like, one of the memory chips basically had a screwed up BGA, and, yeah, at the time, I lacked the skills to fix it. Also, it was a 780 Ti, not a 780, but it used this PCB. So, actually, it might have been a 780. I don't remember exactly. Anyway, Yeah, it's this VRM, and I cut it off, and then I put it on a 970. Um, because this 970 had the VRM die. Like, one of the MOSFETs died. And this is a EVGA GTX 970, and it has an absolutely garbage 4-phase V-Core VRM that dies all the damn time. They're like, these, like, I think I have like 3 of these cards where the V-Core VRM died. One of them is super dead, as in, like, even after e-powering, it's still dead. One of them I haven't tried to fix yet, and one of them looks like this, and has been sitting on a shelf for, like, forever, because I am terrible at, like, making content. I really enjoy doing stuff like this, and then making videos about it is like, why? So I had lots of fun, like, figuring out how to get this board to run. Wait, how does it run? Let me check. Oh. It's very simple. There's a 5-volt regulator hanging off the end of it that you can't see. It's somewhere in this area. Yeah, you can just about see this shadow over here. That should be the 5-volt regulator casting that shadow. Yeah. And actually, what I'm super happy with is this is the card where I realized, like, wait a minute. If the card needs a 5-volt power source, right? Because, like, I've seen other people build e-powers where they'll, like, buy, like, small buck converters off of AliExpress or something, and then they'll have, like, a 12-volt to 5-volt, like, pretty substantial little regulator that, like, needs to take up space on the board. And it occurred to me, like, but the card comes with a 5-volt power supply. Like, it's right there, right? This is the 5-volt power supply. So, like, I could just, like, oh, I don't know, desolder this and move it over here. And solved. No more, like, yay. And actually, like, I ended up also buying a bunch of fixed output 3.3 volt regulators. Though I don't think this thing needed one. Yeah, I think this is one of those wacky, like, sometimes you get VRMs that only run off of 5 volts and 12 volts, and that's really cool when you get one of those, because you don't have to worry about 3.3. And I think this might be one of those. Because I am not seeing where the 3.3 volts is coming in. Like, there's no wire coming from the PCIe slot, so, like, it's not getting 3.3 volts from there. Wait, what's this yellow thing? That yellow thing isn't there anymore. So I don't know what that yellow thing is. I'm looking at the card. It's like, yeah, I'm not seeing that. Is that even attached to the card? Maybe. 1010 heatsink. That's so if you watch GPU repair videos, you'll see some repair people actually just, like, use their fingers to check if the GPU is heating up. I don't like doing that because usually the GPU is covered in thermal paste, and, like, cleaning it is just like, well, you can clean it, but then it's like, oh, but, So I have this little mini heatsink that I can put on, and it's slightly, like, it gives you a little bit more runtime before the GPU gets very, very hot. And also it means I don't have to touch thermal paste. Or, well, I have to touch thermal paste less, because, like, thermal paste is awful, and, it gets everywhere somehow. Every time I, like, swap a CPU, I am covered in thermal paste. Okay, it's not quite that bad, but, like, my fingers are definitely, like, thermal paste, so yeah. Anyway, also, this PCB is really silly. Like, why is the memory VRM all the way over here? What? Anyway, yeah, so that's like e-powers. So yeah, so this got upgraded from, like, a 4-phase to an 8-phase. I have not actually tried to bench the card. I checked that it works, but I've not tried to bench it because it has a heatsink that's, like, really awkward to fit into a motherboard because of where this is. right? Like, this makes it really, like, heatsink compatibility on this thing is a disaster because, like, well, whatever you want to cool it with has to not, encroach on this thing. Um, and so that's no fun. And so I've not really tested it much. I guess I could just run it on a riser. Yeah, I am not very effective at like getting things done. Like the slightest of inconveniences and it's like, "Oh no, end of the world. I need to come up with the most convoluted solution to the most minor of problems." Um and then it's just like, yeah, so like this thing's literally been sitting on a shelf for like months. Actually, probably more like a year. Um yeah. Anyway, I have another dead GTX 970 that was sent to me by a fan of the channel, which also has a vCore VRM failure because it's one of these EVGA ones, and the vCore VRM on these just dies all the time. It's kind of like EVGA 980 Ti's or EVGA 780s. Actually, I'm not seeing a ton of 780s, but 980 Ti EVGA cards, the vCore VRM loves dying. I've also seen reference 980 Ti's with the vCore VRM dead. But the EVGA ones are like super common for whatever reason, and these are also. And actually, this thing is, I think actually Tech Power Up got sent a review sample of it. It's like that VRM is so bad, and it doesn't even have a heatsink. Like literally, they like garbage tier 4 phase, and they couldn't even bother to put a heatsink on it. Yeah. Oh, wait, this is the better. But you can see, like, there's no mounting holes, right? Anywhere around this VRM for a heatsink. Nothing. Not even a base plate. Like, and this is, I mean, actually, this is basically the same thing that I have, except mine is an even higher thermal density. Like, this, you could kind of, well, like, at least the MOSFET, like, you have, like, this group of MOSFETs and this group of MOSFETs, so the thermal density is a bit, like, they've spread it out a bit more. A bit. Actually, I don't think I've seen one of these dead. But there's like the version I have is like the high density configuration of this 4-phase, and it dies so much. So, yeah, also really wacky how like half of the memory chips are on the back and the other half is on the front. Like that's just wacky. I don't think that actually does anything. It's just weird. Oh, and that's the heatsink, just like 3 heat pipes. Oh, wasn't there like I feel like I remember there being a controversy about like, oh, this heat pipe is not touching and that's why the card runs super hot when I'm pretty sure the reason this thing I'm not even sure that it ran that hot. What did it run at? It ran at 74C. I'm pretty sure literally, yeah, it runs cooler than the reference card. Is it loud or something? Oh, I guess it is pretty loud. Yeah, because the EVGA one, like, it's literally louder than a reference 980. It's not, it's about the same, I guess being about the same noise levels as a 780 Ti is kind of a fail, isn't it? Because this pulls like nothing. Oh, 188 watts. Wait, 970s pull more power than 7950s? Huh. I mean, admittedly, like stock 7950s are just pathetically slow because they run at 800 megahertz, but well, yeah. So I'm not sure. Oh wait, no, I do have like, well, I don't have more of this VRM to use on the next 970, but I have other VRMs that I can use on the next 7970 on the next 970. I really don't like the fact that the power board ends up at this like horrible angle because of the display, the DVI port. And it's like, I could probably desolder that DVI port, but like, is that really, am I ever going to use that DVI port? I don't think so. So actually there might not be any downside to just desoldering it and then being able to like, because if you ever wanted to run like SLI, like, yeah, I mean, Getting the bridge over the board is already kind of... Actually, if at this angle, you could get the... Well, no, you can't get another card in front of this stupid thing. So yeah, getting this board at like a different angle would probably be a good idea. So maybe like desolder the DVI port. But I have other testing that I want to do on that first. Anyway, that'll be it for the stream. The card is still running. I mean, even just letting it idle at, you know, in its current configuration is like surprising. But anyway, that'll be it for this stream. Actually for real this time. So yes, thank you for watching. And goodbye, I guess.